Test, Test.
SAP is a global company focused on providing dissolving pulp and paper-based solutions to its customers in over 150 countries. In Europe, we have 10 mills, globally over 12,000 employees, and manufacturing operations on 3 continents and 7 countries.
Good morning. If you have a presentation today, please come to my colleague in front of the room and bring the presentation on a USB drive, or if not, we will give you a USB drive. Thank you.
Hello, good morning. So welcome back, and those of you who are coming for the first day, thank you for joining. We had a wonderful day yesterday, very busy, very interesting. We looked at 10 different presentations from our open call sub-projects, and I think we all can share this opinion that they were really, really good. Some very interesting results of the open call project presented in a very, very good way. So just continue the same thing today with the 10 remaining open call sub-projects. So this will again bring a variety of sub-call projects funded in the 3 categories. We didn't do this type of sorting, so I thought it would be interesting to see how different type of projects are bringing, the different type of value to EFPF. I didn't prepare anything, at the introductory session because the introduction was done yesterday, and I didn't want to repeat it too much. But I just wanted to convey the same agenda that this will be a 15-minute slot for each sub-project. We will have 10 presentations today, and in between those 10 presentations, we've also added a couple of EFPF topics that we think are very interesting and relevant to the open call community and others as well. With that, there will be our exhibition. So we have exhibition area at the end of the room. In that area, we have set up 10 tables for the presenters who will be presenting their work today. We will put some name tags there, and we'll put some scoring sheets there. So during the breaks, coffee breaks, lunch breaks, and at the end of the day, we will have this open exhibition session, providing the opportunity for one-to-one discussions. Partners, EFPF partners and open call partners can mingle among each other and then discuss topics of interest. And it will be more interesting, when you hear the outcomes of the projects, and then you want to dig into the details. You have the opportunity and the time to actually talk to people. So let's make another interesting day. With that, a couple of logistic aspects. So there's tea breaks and lunch breaks during the day. We will the stream will be put on hold, the YouTube stream, but of course everybody will be here. And I also want to use this opportunity to make 2 announcements. The first one is about one of the last event that we are organizing as a EFPF project. It will be at the end of November, and it will be in Brussels. So this event is hosted by Connected Factories 2 CSA project. So this is a project that connects the DT-ICT 07 projects which were funded in the EFPF call, and also develop some synergies between them through identification of common themes and working groups that bring the activities that are taking place in these funded projects on the same page. So this is a 2-day event in Brussels on 23rd and 24th of November, as you can see on the screen. On the first day, this will be a Connected Factories 2 event. So this project is also coming to an end, and this project will showcase some of the achievements and also bring out the contributions of the DT-ICT 07 projects, such as EFPF, towards establishing this European manufacturing innovation space. And you will have the opportunity to learn not only about what CSA project has done, the Connected Factory 2 project has done, but also what are the interlinked projects doing and have done in most cases. So after this first day of overview of the overall domain and the different projects that are working in the same area, the second day on the 24th of November is dedicated to EFPF. So we have drafted a very comprehensive agenda to showcase the achievements and the work that we have carried out in the EFPF project. So it will be more or less a full day of EFPF relevant presentations and discussions. It will be very practical in the sense that we want to showcase the results of the project as they are at this point in time. So less presentation, more demonstration. So and giving people the opportunity to discuss and interact with us. So I would like to extend the invitation to this event to everybody, not only the EFPF projects who have already received some invitations on that, but also the open call partners. Maybe you find it interesting, to see what is happening in the European funded projects, especially the large scale flagship projects. And you'll also have the opportunity for networking and interaction with the like-minded people over there. So this was this will be the last event of the EFPF project, last public event, and I think we can make it we can make it more interesting with your involvement. The second announcement is a bit more local in nature, in the sense that we had a social dinner yesterday hosted by EFF, and I was glad to see that all of you joined. It was a good social activity. Today, since the open call meeting will finish, but EFPF project has another day of internal meeting tomorrow, so the EFPF partners will be going somewhere for dinner, and Dieter, as a local contact point, is in charge of that. So if you would like to join us on dinner, it is on self-pay basis, then please let Dieter know. He will ask now. The dinner will be at 7 o'clock at the location that Dieter will set. Okay, thank you. So with that, we can start the proceedings, and I'd like to call the first presenter to come on the stage and tell us a little bit about the project that they are working on. Agenda. So the first presenter is Eurocat. So we start from here, and the stage is yours. For the rest of the presenters of the day, please bring your presentations and videos to the technical area. So we will use the central system here to project all this information. So if you have not already provided your presentations and demonstration videos, please provide them. So the stage is yours.
So, good morning everybody, I'm Jose Gonzalez from Eurecat, and I will present you what was our project that we have developed for the EFPF platform. The project is called BBI 4.0, that comes from Building Blocks for Industry 4.0. And first of all, I will talk a little bit about Eurecat. Eurecat is a research institution. We do applied research based on, we try to transfer knowledge from universities into private companies in order to develop the technologies that the companies in the region of Catalonia are using. But we are not only restricted to the area of Catalonia, and we also, as you know, participate in European projects and also state projects all around Spain. So until now, we are more than 660 professionals, and the foundation holds about 150 patents. And one of the points is that if one of the research projects give a nice output that it's possible to commercialize, Eurecat supports the researchers into developing a spin-off in order to commercialize the products that it's been developed. So one of the points is that even I am here, Eurecat is not only doing digital technologies, it's quite a large company, well, foundation in which we work in the digital area. There is another part in which they do more industrial technologies, biotechnology, and the last area they do sustainability, in which they work more on circular economy and recycling. So about our project, the idea was that until now, there are lots of analytic tools for large companies. So every large company has a lot of analytical software in which they can analyze the different process. But we have seen from our perspective that there are small and medium companies in which in their work shop floors, they are using still working like if it was 20 years ago. They don't use data. They are not allowed to buy, they don't have enough money, or they don't know the technologies to buy large software that can digitalize their projects and extract analytical information from the data. So the idea was to develop some analytical components that could be used for small companies. And the analytical components that we proposed were a signal processing module, and anomaly detection using machine learning, and finally a virtual sensor that was focused on vibration data. So as I said, from the project objective, we wanted to design and develop some signal processing module in which it will be possible to use this data to extract basic important information. You know, if you have some time series data, sometimes this time series is sampled at a high frequency that is not directly possible to use it for a machine learning algorithm. So our idea was to downsampling the data and being able to use this downsampled data with more variables to use it as an input for some machine learning algorithm. Then we have the machine learning and deep learning module that is used for predictive maintenance or anomaly detection. And finally, there is the virtual sensor that, as I said, there are a lot of processes in which vibration data is used. So now accelerometers cost a few euros. It's possible to buy one. All our phones have several accelerometers. So this technology could be used to analyze several processes during manufacturing. And finally, as I said, one objective was to show all these technologies within the EFPF platform. So just a quick insight with that it's important, we believe it's important for our project. These days we have seen a lot of projects that are based on artificial intelligence and anomaly detections for several processes, but what we wanted to develop was something that was as generic as possible. You know, there are several software tools that can be used on a concrete process, but we wanted something that any company that has data can try to use it and see if it's possible to obtain some useful information from the time series data that they are generating. So the idea of the component that we have developed, as I said, there are the three different components that are orchestrated by an analytics module that it's an internal architecture that can run the different jobs for each module. And at the same time, the internal architecture uses the different EFPF components that are necessary in order to get the data, to return it into the different subscription. You can publish into, again, the EFPF. And also, all this data must be transmitted with some security at the same time that we want to use to allow that any user for our platform, it's just using the EFPF single sign-on registry. So I will show you now quickly how we have developed the user interface. So all the platform works on a web page. First of all, so you have the three different components. You can choose between batch data and stream data. Batch data will be that you have some comma-separated value file and you upload it to the platform. I will show you now. Or streaming data is that you are using the data spine to subscribe to one topic that you have created, and then the results of the analysis will be published again to the topic that you use to get the data. So it's possible to see on each page the different processes that were generated in the past. You can see if the process was finished or it failed for some reason. Inside, you will be able to see why it failed or if it was finished, all the logs. So just I will show you how it's the final page for, so the result page for each process. Just this is the signal processing module. You upload the data, you can choose between different statistical descriptors, and there are different options in order to downsample the data and process it. So once it's been processed, you can, so all the data is plotted on the same graph. Maybe this is not very useful if you are extracting metrics that are very different on the order of magnitude. But in order to allow the future analysis inside the factory, you can download the data. This is just if you want to transform some high frequency data into a lowest frequency data that it's more easy to understand. But as I said, there are other components for the acceleration analysis. You have, this is the different, well, the different processes that you can see that were executed in the past. This is the page in order to create a new process. So I will show you later how it works. And the result is that you can see that there are two different analyses. The first one is if you uploaded different files with different timestamp, well, different sections of data of the acceleration with the 3 axis vibrations. So you will have first on one side the Fourier transform, this spectrum, shows you if there is some kind of vibration that is generated during the process that you are measuring, and these harmonics can show you if something wrong is happening in a process. It's very used within rotatory machines, and the fact that there are different, that you can upload different files will allow you to compare different days of data or different, well, timestamps, just moments. On the other side, there is the axis in which the accelerometer is vibrating. Sometimes it must be that there is some drift in the machine, and this tilt on the vibration might show that something is happening within the process. So the final component is the anomaly detection component. There are two different steps. One is to train models, and the second one is to analyze more data with the models that you have trained. If you train the one model, so you can see that it will show you the data that you have and the data that you are predicting. In this case, so sorry, it's just doing the analysis. So first you train, as I said, and then you analyze more data with a model. I will show you later. But that, so the final page with the results, you can see the difference between what you have on your data, what you are predicting, and also some anomalies are shown on the plot. In this case, there are a lot of anomalies because you can see that there is a large difference between your input data and your prediction. So just a quick demonstration. This is for the accelerometer. In the case of the acceleration, as I said, you have seen the result page, but in order to upload it, to create one process, first, well, on the page with all the jobs, you can start a new one. There is some place to place a name, to describe the analysis that you want to perform. You can upload different files. As always, the data should be comma-separated value data with the three-dimensional, the 3 axes for the vibrations, and then you have the different, well, parameters that now, okay, are not very important, but just have in mind that it's possible to change the different values. And now, so you see that there are the finished process, and the one that it was run, it's still running. It should be a few seconds in order that the process is finished. And then once it's finished, if you enter, then we will see the result page that I showed you before. So now you can see it's what I showed you before. So then there is the one for the different anomaly detection. On the anomaly detection, it's the same. You see the processes that are running. Also, you can see that there were some processes that fail. If it fails, you can enter. You won't see the result, but there is a log in order to find what was wrong. So as I said, now we are creating a model. On the model, it's not that you just upload directly the data, as I have said several times during this presentation. Sometimes time series data, it's sampled at a high frequency and it's not useful to train machine learning models. So one thing that we did was to implement the different signal processing module before the data is fed into the model, in order to have some data that has different variables. So in this case, in addition of the pre-processing, you can choose different models. There is a deep learning model, long short-term memory neural network, that it's a model that tries to extract some time information in order to predict the future. Also, there are 4 different standard machine learning models that are isolation forest, one class support vector machine, LOF, and KNN. So the point is that all these methods are unsupervised machine learning methods. If you know the difference between supervised machine learning and unsupervised machine learning, in this case we have preferred that the models are unsupervised, because sometimes there is not enough data to say, now we have several problems at this point, you are not able to tag your own data. And for this reason, we prefer to use some models that just try to find anomalies. And with these anomalies, you can see if those relate with problems that you have in the factory, or if the accumulation of several anomalies means that each time something is going wrong, now you don't see the problem, but maybe in the future anomalies are increasing at a higher ratio, and then you could predict that something, maybe you need to check if something is wrong in your machine. So from the dissemination part, we have participated in one ESA conference that was held in Valencia in March. Also, we have participated within the EFPF events, and inside the company, there are some mailing lists in which we are explaining what the project is about, in order that, as I said, EURECAT, it's quite large, so some people that are in the industrial area that could be useful for them, the models that we have developed, acknowledge that we have worked on that, and maybe in the future they will be able to use it. Maybe not our models, but maybe another EFPF component. So quickly, as I said, from the EFPF, we have used the verification of the user, and also we use the data spine in order to publish and subscribe to different topics. So finally, to summarize our experience, as I said, this has been our first experience with the EFPF platform and community. We have seen that the project is very large. From a point of view, we saw that first, when we start, it was like still the platform required many updates. Now we have seen that the project it's going on. It's been a large evolution since we start until now. We know that there are still some points that should be improved, but we have seen that you are working, and we will see how this evolves until the platform is launched to the market. Also, we want to say that the biweekly meetings with our supervision from ADIME, it was very helpful, because if you don't know the platform, you need someone that introduce you between the different components. Also, you are a lot of partners that we don't know to who we should contact for each DApp. So he was really the fundamental part to conclude the interaction between our module and the EFPF platform. And just to say that the final point is, okay, we have seen that there is some evolution. The commercialization of our application will depend a lot on what is decided on the future months. So now it's quite open, but just as we talk with you, and the platform goes from this small community to the wide public. So we will talk with you, and we will try to decide which one is the best commercialization path. So thank you very much, and I'm sorry it took much more time than what was expected. You're welcome.
The next presentation is from AI Challenge.
Hello, good morning. Hello, good morning, everyone. My name is Antonio Vicente from Artificial Intelligence Talentum, and I'm very happy to be here to share with you our proposal, our project Go Green. Let me start giving you a brief introduction about our company and our Go Green project. Artificial Intelligence Talentum is a young company based on the southeast of Spain, and our experience focus on machine learning, software development, and intelligent IoT devices. We are expert in the design and development of artificial intelligence algorithms and the digital twins. Carbon emission and water consumption were the main drivers for our proposal. Why? Because carbon emission are the primary driver of global climate change. I think it's one of the world's most pressing challenges. And on the other side, the water is an important resource in many production processes. And the reduction of the water footprint is as urgent of the carbon one. Let me bring into my speech the word of the Prince, the King Charles III, in the opening of the conference of the party the last year, who said, "World would need ways of calculating emission, and due to the progress of the companies to the net zero strategy." Why? Because I think understanding the difference between carbon neutral and carbon net zero is critical. Carbon neutral refers to the policy that not increasing the carbon emission and achieving the reduction of emission, offsetting this emission. On the other side, the carbon net zero is the most ambitious program, is change the processes to reduce as low as possible the emission, and the rest of the emission be offsetting. Our vision is to go to the net zero, change the processes of the company to reduce the emission of the carbon emission and the water consumption. Our platform, Go Green, is a digital twin for the quantification of environmental impact, CO2 and H2O, water footprint on industrial processes. Let me know right now to the overview of the project, with more specifically to the project objective. Our two main project was, first of all, give to the factories a reliable tool to calculate and manage the carbon and water footprint, and Secondly, to integrate the tool with EFPF, because it helps the factory companies with the next zero strategy. But from our side, as a business company, from our business perspective was to expand our portfolio, focus on climate change, and to go to the market, to the European market through the EFPF marketplace. Right now, it's time to talk to you about the technical achievements, and to do that, keep in your mind that there are a lot of free tools or providers of the evaluation of the carbon emission. But I think our vision was try to include in this evaluation all the scope in the problem. The scope 1 and 2 are totally treated by practically all the tools, but the scope 3 is the problem. All the emission associated with a company's activity is very difficult to have a good conversion to calculate or make a trusted evaluation of the real carbon emission. 2 years ago, we started with our proposal with Go Green, making a integrated web base to get the calculation about this environmental footprint. And the most important thing for us is the use of standards, DEFRA, GHG, carbon trash, global water footprint assessment, standard, and so on. Relating to the technical achievement, I want to show you the architecture that finally our proposal was made. In this slide, you can see two modules. The module named Go Green and the module named Core Go Green. The Core Go Green is where it's like a engine where we made the right calculation, and the Go Green is the user experience interface with the user or with the customer. And around this, we can see our integration with the different components of the European Factory Platform, AFS, key clock, or marketplace, or external node to use the blockchain utility. Go ahead to the KPIs. We planned 5 KPIs. One of them it was very difficult to reach, but at the end we can to reach out our results. And the KP1 is enter a new market. Yes, our solution was integrated in the EFP marketplace last week. And relating to the KPA2 focus group, we made 2 focus group with 5 people. And most important, relating to the live demonstration to the platform, we made 3 live demonstrations of Go Green to different kind of customer. And relating to the number of posts in social media, at least 1 publication, we overpass this, make a lot of publication and dissemination tags. And finally, the number of hosted workshop, we was included in a workshop, a technical workshop where the platform on the Go Green and this project was has been a specific tool. Relating to the development of the plan made, the plan was made for 9 months. At the end, our main delay was in the prototype, in the integration, in the piloting, because our system integration was difficult in some kind of parts, in some component was very, very difficult to have a good interoperability with this kind of component. At the end, our two components were integrated, key cloud and marketplace. Other component like this match gateway was evaluated. We carry out a lot of trials with them. It promises a good result, but we don't have operative installation to check in this component. At the end, we made just laboratory tests, but it was very, we expected a good result. Relating to the component not integrated with the DNML blockchain, because at the end we have the information was provided so late, we can't to integrate this module in our solution. It's time to see the platform. I want to do a live demo, but it's better to make the video, please. As a final comment, it's important to say that we said that blockchain is not integrated, but the blockchain module is running in the platform, but it's running through other different layers, named Alastria. But at the end, our future work is to move this kind of solution to the module of EFPF. Okay. This kind of the solution is available in this website, and you can see, you can try and you can find out where is the main utility for other company. Let's move on now to the dissemination results. And relating to dissemination result, we work a lot, because I think during the last period, the last 5 months, we tried to have to pushing up this solution as a way to be a reference into the carbon water footprint evaluation in the manufacturers in Europe. Relating to that, we made 3 live demonstrations of the platform. The first was to Eroski, Spanish supermarket chain, and the idea was try to have a real feedback of the customer in different area, to have to the next state for this platform, because it's not just for manufacturers, it's for all the kind of company, and try to collect all the data. We make a live demonstration in supermarket, in a processing company for leather, in a company of utility water in Spain. Our feedback was nice. Really, the most of the company was interested in this solution, and probably in the future we can to expand the scope of this platform to other kind of companies. Due to our activity in the social media, we made a lot of dissemination of the results in Twitter, LinkedIn, blog posts, and so on. You can see this reference in this different point. And the most important for us was this dissemination activity in the technical workshop with a large number of participants, maybe 100. The target audience was CEO, quality and product manager, engineers, and the website where the event was announced was like this. It was like a focus group, because some of them never know this kind of solution. Finally, relating to dissemination results, in our website we included a landing page designed exclusively for the Go Green platform. This page we display the different sections of the platform, include reference to EFPF, and recently we will update this page with our next step for this proposal. Dissemination result, speaking about technical conference and paper, was made through 3 different papers. 2 of them, the first and the second, were not accepted, but the last of them was accepted and will be published depending of publication in the next month. It was a good news for us. At the end, but not least, the exploitation plan. The way that we got to get the money, or maybe to go to the market. We planned to do a subscription, and finally our business model was a subscription, the software as a service, because we need to update the factor conversion each week or probably each month, and there is not way to be just a licensee. We need to software as a service to give a good service for the end user. This software as a service will be offered in 2 different ways: for end user with a model of business, and for for developers and integrators. For end users, initial setup is 200, as you can see, 2,500 euro, and annual fee, recurring fee for 450 euro. relating to developers and integrators in the EFPF. During the development and integration, there is no fee for them. And later, when the SAT project will launch, the annual fixed fee is accessible 1,300 euro. In this slide, in this show screen, you can see the software published in the marketplace, and this was the last point to be running our proposal and to offer our proposal to the rest of the components, the developers and the end users. And finally, positive remarks and improvement suggestions. It's important because I think most of them, this question was one of them was result. Our result was our impression, our feeling is good, it's very good, but because I think right now we are a part of the European ecosystem of solution for the industry. We can access to components and modules with powerful use in our application, and we have a close collaboration with a assigned advisor, special team for us. But there is there are things to improve. The technical deployment of some of the components was not available, as other partners said, and sometimes the documentation was not complete or was not enough clear from our point of view, for sure. The most important, long time no get answer to some technical issue posted through Tiki, because I think it's not seen, there is not a real or a trusted way to solve the technical issues. Just a suggestion from our experience, a welcome program to the new partner involved in project would be technical workshop or video tutorial. I saw this is in November. There will be one, but it could be a good idea to help to reduce the apprentissage period from us. Let me finalize my intervention with a special thanks to our advisor for IDIME. Thank you for all of you for your attention today here. Thank you very much.
Good morning. Yes. Good morning. I'm Malva Dominguez from CITAG. The subject of this talk is to show the obtained results for the PREMAR project. First of all, let me introduce to the companies that belongs to the consortium. Cabomar Congelados is a company located in Spain. It's a fishing company with the purpose of importing, exporting, and marketing and handling fishery products and all kinds of food in general. Mainly, it is dedicated to the transformation and commercialization of fish products through distributor brands. CITAG also is a company located in Spain. Is the Automotive Technology Center of Galicia. Is an entity dedicated to the research, development and technological innovation in the automotive sector. CITAG works in the different stages of the development of the new products and process. PREMAR, monitoring and analytics and predictive maintenance in machinery in Cabomar, is a project that aims to prevent machinery failures in the fish processing industry by using the EFPF tools and platform. As you probably know, fish and seafood manufacturing is a harsh environment in which usually the machinery suffers high rates of unexpected failures that cause large losses. As a solution, Cabomar and CITAG aim to integrate the EFPF platform and tools into the line, validating these tools and sharing the learned lessons with the community. Premar has some objectives. CITAG and Cabomar wanted to integrate the EFPF tools for the prevention of the existing failures found in the machinery in Cabomar, and improve the reliability of these machines in the manufacturing environment. The validation and testing of EFPF tools for integration and interoperability would be performed. The tools was integrated with interface with one Cabomar machine. Once this was done, the validation and the testing of the EFPF tools would perform the factory connector tool for the monitoring, the real-time anomaly detection, and the predictive maintenance. These tools would be tested in one machine. As a dissemination measure of the project, at least 4 events would be used to disseminate the results. In this slide, we want to talk about the components and the architecture for the project. The initially selected components to solve the Cabomar predictive maintenance objectives were the data spine, the real-time anomaly detection, and the predictive maintenance tool with the ROAM, deep learning toolkits, and visual data analytics. The architecture, the initial idea for the architecture was a local server located in Cabomar to collect the data from the machine with the existing failures, and the EFPF cloud where the tools would be running for obtain the expected results. The analysis was performed in 2 stages. First, a historical training stage in which we would manually create a data set with the composed by the historical registers of the machines, with all of the stops and all of the historical registers. In this case, we would analyze the thermoformer machine. Lastly, a real-time operation stage in which the data will be transferred from the field machine in Cabomar to the cloud, all of this in real time. During the project lifetime, we have also had some issues. In the phase 1, the evaluation of the platform was raising a series of issues related with the availability of the tools, documentation, bugs, and other typical problems with developing a new platform. With some of the tools, they work, but without obtaining the expected results for a company like such as Cabomar. Sorry. In the phase 2, the timing between EFPF and Premar caused that at the end of the Premar project, it's a short validation project, the platform was not fully ready to use for an autonomous use by a manufacturing company such as Cabomar. Also, the tools work, but without the obtaining results. With some of the tools, we have performed partial proofs and all of this. From Primar, hints and recommendations were provided as end-use feedback. Here we present the deviations from our work plan and the actual KPIs against the initial one. As commented before, the overall timing issues between EFPF and Primar has caused to test an unfinished version of the platform, so it has not been possible perform a proper integration of the tools and explain the origin cause of the machinery stops in the provided datasets. On the other hand, the chosen tools, the initially chosen tools has changed to the anomaly detection tool, the predictive maintenance tool, and the predictive maintenance tool with the ROAM, the deep learning toolkit, and the visual data analytics. The validation process was performed on 2 iterations. All of these documented in the deliverables of the project. And the KPI 4, 2 machines monitoring and analysis with the real-time predictive maintenance tools, was updated to 1 machine during the project as agreed with the Primar coaches. For each machine, 52 process variable was being selected to be part of the study, and it has not been possible to reduce the annual number of incidents due to the already mentioned timing issues in the development. During the project, we have also had some dissemination results, such as physical events, LinkedIn posts, news on consortium's websites, and open call related interviews. With reference to the exploitation plan, Primar, as you know, is a validation project, and its focus was to integrate the EFPF platform and tools and shared learned lessons with the community and provide a good feedback to EFPF for the development. The usage of the platform could generate potential revenues up to 94,000 per year. And the support to other manufacturing companies would generate potential revenues up to 35,000 after 3 years. All of this conditioned by a further maturity state of the platform. To summarize our experience, Primar was conceived as a validation project to perform a constructive and objective testing of the platform from the point of view of a real manufacturing company with real processing failures. The performer validation shows that EFPF is a promising platform with very interesting features that can be useful for the specific problem existing in Cabo Mari and other companies. Primar has made a new experience in European projects for Cabo Mari and CITAG. And additionally, Cabo Mari has approached its digitalization challenge using a different perspective, which will be useful in the future. Finally, we want to thank to the EFPF team and especially the IDIME team as coaches for the help, the weekly meetings, for all of this contribution to the development of the Primar sub-project. Thanks for your attention and thanks for the opportunity.
The last presentation is from a 9-month experiment, SAPI, but unfortunately the presenters could not be here today. What we have got is a presentation and a video that hopefully will explain the experiment and the work carried out in that experiment. So we will showcase this experiment here, and for any further discussions we can provide the contact details of the experimenters.
Thank you for the opportunity to present our Type 2 project titled Anomaly Detection on the Edge for a paper mill. My name is Javed Khan, and I'm with the digital transformation team at SAPI Europe, based in Brussels, Belgium. SAPI is a global company focused on providing dissolving pulp and paper-based solutions to its customers in over 150 countries. In Europe, we have 10 mills, globally over 12,000 employees, and manufacturing operations on 3 continents in 7 countries. Since this was a Type 2 project, we collaborated with Scalable, a Dutch startup company based in Eindhoven, which focuses on edge AI solutions. To motivate our work, I want to take a minute and talk about paper and paper making. Paper is an important material used daily for many purposes worldwide, which one takes for granted in virtually any context, whether workplace, home, or on the go. Paper has a plethora of uses in everyday consumer and enterprise life. These uses range from printing books, magazines, leaflets, and advertisements, to packing food and medicine, to applying patterns to clothing, laminates, and other products. Yet, although producing paper can be traced back almost 2 millennia in China, the paper-making process is far from simple, requiring large and complex machines. Originally, paper-making was a slow and labor-intensive process. However, today, paper-making is driven by capital-intensive technical equipment and high-tech and high-speed machines that produces a roll of paper at a speed that may reach 2 kilometers per minute and with a web width that may exceed 8 meters. Although the machine itself and the process around paper making generate a lot of data, data science and AI solutions are very new to the paper industry, and therefore we're very grateful for having the opportunity to collaborate with EFPF and Scalable. Our objective was to use EFPF's models to detect anomalies in the production process of paper directly on the edge. Edge deployment, i.e. in situ as opposed to the cloud, reduces latency and energy consumption, among other benefits. And essentially, the main idea is to try to detect anomalies in one of the pulp post-refiners. That is very early in the production process, to be precise, just before pulp enters the headbox of the paper machine. Such anomalies now might explain subsequent web breaks, and preventing web breaks means securing continuous production and therefore avoiding costly stoppages. As I mentioned, this was a Type 2 project, i.e. a 9-month validation project with 2 partners. And validate EFPF's anomaly detection models by using this in the paper-making industrial context, and further validate the EFPF's algorithms and Scalable's platform for edge deployment of trained AI models were our primary project objectives. Now, a brief overview of our technical achievements and outcomes. First, accuracy of the model. The accuracy, i.e. the inference of the edge deployment, are the exact same as those running in the EFPF cloud. The process of converting from the EFPF service to an edge-friendly format, i.e. to ONNX and WebAssembly, is effective. That said, more effort remains for further improving business processes. At this point in our work, we primarily value the experience gained by moving this functioning model to the edge, and we assume we will be training more elaborate For example, higher dimensional models that also take the temporal aspect of sensor signals in the future. Next to the accuracy, we also critically examined the usability of the whole edge deployment process. We found that moving between platforms, i.e. from the SAPI digital twin to the EFPF platform and from the EFPF platform to the scalable platform, was somewhat challenging due to changing formats, for example. But within the platforms, training and edge deployment worked pretty much effortlessly. We feel only minor engineering is required to smoothen up the transitions. And from that point onwards, EFPF training combined with scalable edge deployment would provide an out-of-the-box solution for the edge deployment of complex models going beyond our case study to the industry. Furthermore, some words on the execution speed. We monitored the execution speed of the inferences. Due to the low level, i.e. WebAssembly implementation by Scalable, and the relatively simple k-means inference model, execution speed was not at all an issue in our evaluation. We have managed to process over 100 data points a second given the current setup on the selected edge device, with execution time obviously depending on the selected hardware, which is orders of magnitude faster than necessary for the current use case. Finally, some words on response time. Prior to training to automatically detecting anomalies on the post-refining process, any inspection in that part of the process was done manually and only occasionally when, for example, production issues were observed. Based on anecdotal data, the response time would be at least hours. In the best case, due to the manual effort of the process, as you can imagine. With the automatic inspection of the machine learning model, the response time to detection of anomalies is decreased in few minutes, 1 minute for sampling and 1 minute at most for processing. We would like to highlight that although the machine learning model can potentially alert a process engineer in the mill environment, manual action would still be necessary in inspecting whether there is a problem, such as broke creation, in subsequent to post-refining post-production steps. Nevertheless, with this project, we have put in place the first step in further automating the digital monitoring of that early part of the paper-making process. At this point, I would like to demo 3 salient steps of the process. First, the use of EFPF's platform for training and exporting the k-means anomaly detection model. Subsequently, the use of Scalable's platform for creating an edge-ready model. And finally, the execution of that model for inference with data stemming from the paper machine. So after login with our credentials, we navigate to EFPF's anomaly detection service. Which you see right here. Now here in the model manager, you can see that we have experimented with different trained models, and we choose the one which worked better for our context. One then can easily download the trained model. Once exported, and with the help of Scalable's expertise, this model was converted to the Open Neural Network Exchange, or ONNX format. Effectively, an ONNX graph describes the conversion of inputs to outputs. A graph specifies the order of operations. The edges in the graph are tensors, passing from one operation to the other, and the nodes in the graph are operations to be carried out on the input sensors. Here you get a glimpse of Scalable's platform, which simplifies the deployment and management of models deployed on edge devices. Finally, a short video showcasing the execution of the edge deployment model with data stemming from the paper machine. In this case, you'll find out that the anomaly was detected by the model something we did validate with process engineers who are ultimately the domain experts. Now, on impact achievements, to begin with the dissemination results, we have held, for example, a workshop for our SAPI data science group, executed by the CEO of Scalable, Professor Dr. Moritz Kaptein, on the topic of ONNX and broadly on edge computing, with data scientists participating from several European countries and South Africa. Due to persisting COVID restrictions, we reached out to one more SAPI mill in Germany, where we discussed the needs of that mill in relation to EFPF. And finally, we authored a white paper which we circulated in our data science community titled "The Promises and Challenges of Anomaly Detection on the Edge." Now, on the exploitation plan related to EFPF outcomes, we see a potential of the anomaly detection model for training purposes. For example, we envision junior, inexperienced process engineers receiving reports from the anomaly detection model. Those reports, which could also be in real time, could serve as an extra validation check of the status of the post-refiner part of the machine. In future, we want to further evaluate our results with process engineers to confirm their validity and subsequently investigate it in an iterative fashion. How should we present the results to inform process engineers and identify other stakeholders who might benefit from such results? Some of the actions we envision machine operators could take include add anomaly detection statistics to their daily and weekly reports, or have anomaly detection statistics be a topic in their progress meetings with other engineers and management, and based on those, change the consistency of the pulp in the post-refining process with an ultimate goal to semi-automatically control the pulp's consistency. To summarize our EFPF experience, we found very insightful to experiment with the EFPF platform. Beyond anomaly detection, we have identified multiple more useful services, which goes, as you can imagine, beyond the scope of our project. For example, the risk opportunity analysis and monitoring tool by EFPF, which has a risk recipe component. For the scope of our project, we found the anomaly detection algorithms easy to use, and we have suggested to EFPF possible extensions to time series models, which also, and the whole project sparked a meaningful discussion of in our data ecosystem. And our future work includes fine-tuning the existing model and validating it, as Ford mentioned. Going beyond technical and usability matters, we would like to make a more general point that we felt when interacting with EFPF's specific anomaly detection. At this time, there are also other similar online services. And for a newcomer, it might be unclear the differentiation between competition. So we would like to also have this as a suggestion to EFPF to kind of clarify the differentiations, for example, with Amazon's anomaly detection service. Having said that, our experience is that throughout the project, that was very well supported by the EFPF team, support by both our advisor, Stefano, who I would also like to take the opportunity to acknowledge and thank, and obviously EFPF at large. And with that, I would like to thank you for your attention.
Okay, so thank you, Javed, if you are watching through YouTube. So we found it very helpful, insightful to understand the project and what you've done in the project. With that, we reached the end of the first session of the day, exactly on time. So this is really amazing how things are working out in this meeting, you know, to be exactly on time, on their own. So thank you, and we take a short break, a 30-minute break for coffee, and we will be back with more presentations at 11 CET. See you in 30 minutes.
Bin ich drin?
Hörst du mich?
Ja. Dann, ich versuche mal eine Präsentation zu starten. Okay. Dann sollte ich versuchen, mal den Bildschirm zu teilen. Share the screen. Okay. Share. Ja. Mhm. Genau.
Ihr Mikrofon? Im Teams einfach auf Stummschalten.
Okay. Verschwunden.
Test 1, 2, 3, Test.
Okay, so it's time to reconvene and restart the next session. I hope you guys had a good coffee and a good opportunity to talk to each other. Let's find the seats and let's start the proceedings once again. So in this round, we again have a handful of very interesting EFPF sub-project presentations, and this will end with the session from EFPF, where we will showcase the marketplace, EFPF marketplace as it is, as people have been using it, what are the enhancements that have been carried out lately, and what are the enhancements currently in the pipeline. But let's start with the next round of sub-call presentations, and the first in line is the presentation from NISA Tech. Thank you. So I'll give it to Nina.
Thanks. Hi. Yeah. Yeah, das habe ich schon verstanden. Wo sind meine Slides? Danke. Hi. Good morning. Wow. Okay. I'm really glad to be here. First of all, thanks to the project for selecting us, for really doing a very good mentoring process to follow all this, what you need in order to boost the innovation. We are an SME, and boosting innovation is always an issue. I will have a separate slide for this. So first of all, thanks. Second, what I'm presenting is probably a little bit different than what you saw in previous presentations, because we are talking also about something which is close to be the product, and I will be also showing the development in that way. I'm Nenad Stojanovic, I'm CEO of NISA Tech. NISA Tech is a company, you see, creator of innovative green solutions for challenging industry problems. So this is what we are really trying to do. So very hard problems which should be resolved in a very smart way. Currently we are doing a lot with the cognition, so this is something where we are moving, so beyond AI into the cognition, very strong data analytics, different type of technologies related to the data processing. Actually the headquarters is in Serbia, but management is in Germany, so we are very driven by let's say European market, and we are trying to be really the leader in that what we are doing. There are a couple of the products which are based also on these technologies. Now, what we have done in the project is that we have tried to do a completely new way of looking into the product control, monitoring and control, or process monitoring and control. So involving some kind of self-assessment test so that the companies can do this very complicated stuff which is related to the product quality and process quality on their own. And this is why it's called D2 Health, so data-driven health. We are now changing a little bit the name because of the promotional reasons, but the main point is how you can understand actually the process behavior based on the data. And the last paragraph is extremely important. I'm very strong, I'm very strong in data analytics, and there is a huge gap in the whole community because usually we are forgetting that the data in the industry are coming from the processes. You just think, okay, data is there, but actually it's coming from the processes. Processes has kind of behavior because they are very strong and they're producing some kind of KPIs. And that's what we're also doing in this project, and what we're also doing in general is combining data analytics and process analytics in order really to have very strong results which are industry relevant. This is the architecture. Obviously, there was a team of people who was doing this, plus mentors, plus support from the EFPF, and I'm not the main responsible really for doing really this. I'm a technical guy, but not anymore very operative. So that's what you see here is a general architecture. We can go into details, but mostly we have used the services for getting the data from the industry facilities. And this is why mainly we are playing with the data. We are mainly playing with the broker and the possibility to get this heterogeneous data in a kind of asynchronous way, which is enabling us there to process this data further. There are two types of the analysis we are doing. I'm going very fast through this, let's say, official part because I will have plenty of examples. We are doing this analysis in an offline and online manner. You see also the role of the EFPF technology here. But the main point is, as I already said, this new notion of the process health. And the KPIs are also related to this kind of validation. First of all, we would like to understand how we are understanding the process. So this process understanding, we can develop different type of the methods because it's really difficult to understand the process. Then the user experience, because that's what we are delivering is for the industry users. And the third one is the business value. Okay, even if you are presenting results very good, is there a value for the business guys? Now we are coming to the explanation of everything. That's what you see is the standard statistical process control chart you can find in a let's say usual company. There are different type of these charts. They are univariant like this one, but what is most important, you're separating your world into the green and the red. And okay, you see here everything is green, everything is fine, everything is okay. This is from a real industry customer. But you also see that there is a kind of distribution of these greens. And you see some are more close to the red, some are really like this. Okay, I can use also this, like this one. They are really, really centered. They are a little bit dispersed. And you can also somehow validate this, that this on the left side are like a biased, unstable, great. What is the issue? This black white or this green red is a problematic, because even if you think about it, we are always doing this because we are trying to explain our customers what we're doing, and we are introducing these blood checks. So what we are doing actually, you're giving us the data. This is like you're giving the blood to the medical doctor or whoever, and then you're analyzing these things. So this is exactly the analogy we are following all around how we as a people are doing these healthy checks. And this is a trivial example, but you have this blood pressure, and obviously you have the normal and high and something in between. And this is the issue. So we have always something in between. You always have something in between, and this is also here has something in between. Now is the problem how you can find something in between if you have the tools which are not talking about something in between because they don't understand the process behavior. And this is how we are now trying to attack, or how we have tried to attack the story by actually understanding what is this in between and how you can analyze this in between. And this is now another analogy, because as I said, we are going into another domain, on another, let's say, level of awareness in the industry, and we had to introduce a different type of the examples. This with the shooting is extremely efficient, so everyone understands. Even we are doing different domains, oil, gas, even in fitness. So that's what you see as a bias, is if someone is shooting, as you can see, a little bit on the left. If you are unstable, this is like this one, and if you are good, this is like this one. And everything is okay. It's okay. You can score the same. But what is the issue? If you think about this from the process analysis point of view, you have a huge difference. This first one is biased. It can be improved. It has to be improved. But it is okay. It is stable, but should be improved. The second one is extremely critical. This is the unstable process. And if you think about the management or process management theory, if you have something which is unstable, you cannot predict its behavior. So the issue is you cannot predict. Even if you think about shooting, you cannot really predict where will be the next shoot. You don't know really, because it's unstable. The third one is great, and this is what we are doing, and we would like to move the process into stable state, because then you can analyze and predict. And this is now quite difficult, because these are also interesting. I like KPIs. It's really, really great. What is this? These two KPIs are completely identical, so 70-70. But it are extremely different in the behavior, extremely different in the future, extremely different for the process owner. And this is the main topic. If you are going to this black-white, is good or not, KPIs, not looking into the nature and the behavior of the process, you're lost. This slide, I like this slide. It is out of scope, obviously, but this is the theory. So we're talking about process capability and stability. These are two dimensions if you're talking about process management. Capability is voice of the customer. Are you targeting exactly the customer's, let's say, requirements? And stability is the voice of the data, is how your process is stable, and it's exactly related to this, what I just explained about predictability. And you can see unstable process, you see a stable process, and you stable process, which is actually incapable, because these are going beyond the specification from the customer or whatever thresholds we are using. Okay. Now I have one video I will be asking you for starting. Thank you. It is 1 minute, which is there is no sound. I am covering this. where we are explaining actually our deployment in the industry. So we are a company which is dealing a lot with the real industry, and this is deployment of the system. As I said, we are using EFPF for collecting the data. This is metal cutting engine, plasma machine, where we put the sensors, and you can see actually when the thing is doing something, we are collecting the data, and this data is processed. The main goal of processing this data is to building the models, which will appear in a second. And these models are present. This is again one of the innovations. So they're present in a different way. These are so-called variation and outlier charts. I will be giving more details. Then we can find root cause. Based on the root cause, we can go into the parameters because it's a multivariant analysis. Which of those parameters are really critical? And the benefits are for everyone in the chain. So we're talking really about here data-driven chain, producer of machine, producer of the service, and this is the future of the process analytics. Now back to the presentation. Thanks. Back to the presentation is actually explanation what is our main result. So we use the, if you, back to the presentation means me. We have different type of the charts. These two are here because I mentioned already these process outliers, they belong to this capability, and this process variation belong to this stability, because outliers are something when you're going statistically beyond some of the thresholds. And this is actually how we are interpreting all this. So you have different types of the reds. Reds means that you have the data points which are outliers or unstable. Green is okay. Yellow is something in between. But actually what we are giving to the customers is this kind of the shooting interpretation that you see different positions. I have to look on the time. Okay. And we are also finding root cause, as already presented in the slides. So you can find the root cause. Root cause in this case is energy domain. You see different type of the causes. Again, we can always interpret this as for example, in this case, as a bias. We can play with, so the tool is enabling different type of playing with the root causes, and you can find root cause for this parameter is causing which kind of the problems. For example, you can find the different parameters are causing different type of the problems. And now I'm coming to something which is completely new, and this is that we went beyond this analysis of the shooting maps, and just be probably more focused now because the switch is huge. We are moving from understanding the process management, stability, capability, into understanding process operation, the nature of the process. Not anymore meta level, is this stable, can I predict, but what the thing is doing. And this is something when we went into process mining. It is a huge discipline, but this is a different type of the process mining. So we are using, with the early method, we are enabling us to also understand which process modes are there. And this is what you can see here as a green, yellow, pink, or whatever. So we have developed the methods which are enabling us based on the data. Everything is unsupervised. This is the tool affordable for the SMEs who don't have the expertise and so on. So we are automatically, let's say, discovering the modes. We cannot interpret all the modes, but we can, based on energy data, do something. And this is really now the big picture. We have the data which is coming from the process. We have our models which are coming from AI, and then we are coming back to the real world in order to understand, okay, what is actually the reflection of this, what we are doing in the, let's say, digital world, on the real world, what are the actually processes. I have a couple of slides more which I went quite fast, not because of time, but because of, you will see the nature of the slides. So we have the modes, and what we have started to understand, what is the impact of these modes on the energy and the environment, because this is now extremely important. And you can see that different type of the modes, machine is off, machine is on, machine head in motion, machine is operating, cutting, mode 1, mode 2. All of them can be discovered, as I said, automatically, and all of them can also have a kind of the impact on the, in this case, energy. You see, cutting mode 2, cutting big loads, require more reactive power, cause additional heat losses and energy costs. Mode 1, bigger current distortion, which is introducing some kind of the problems for the whole network. Then we have also went into the environment, and then we have seen also how these modes are introducing environment effect. Temperature is increasing. You see the particles. This pink is one, and the yellow is another mode. Sound is different. So we went into really understanding what is going on the really high granular details, and you can see that mode 1 has great impact on the environment, as put here. here, great power of the energy consumption from cat mode 2, and these are the results we are now validating also with the customers. We are extremely disseminating now. We have some dissemination related to the customers. You see the names. We have also some presentation which are partially because it's a huge theory behind which we are doing. We will have a big presentation also on this IM4MS stakeholder event, presenting the results as a successful SME. Please, this is a promotional video we are now doing, just to give you also the flavor in which direction we are going. It's 1 minute, it's really attractive. Give me this opportunity, please. Sound is important. So it's 1 minute. It's called D3 scan. Thanks to, oops, sorry, one slide more means this one. Thanks to the project, really. I have a lot of experience. It's extremely good mentoring process, extremely good. I changed 3 mentors, and I have to say each of the next one was the better. Let's say the first one was really good, and the next was better, and the third one was extremely good. So obviously there is a good mentoring process. Reporting, great, absolutely great. So I really like that you have really clear requirements, and we can satisfy it, and then is a talk to the mentor, everything is great. The third is very important, a lot of freedom for us, a lot of freedom. So yes, we use the platform, but I was not bound by this, okay, you have to do this and that, but the freedom was given to me. And this is very important because we could do really this very risky innovation. You boost innovation, and this is the last statement here. We are really going into the developing new view because we started with this data-driven healthy check. We are now really into this sustainability check or sustainability monitoring and control. And I'm really, once again, very thankful for giving us this opportunity. Thanks. Hopefully, we will be cooperating in the future as well. Thank you very much.
Thank you, Dino. So thank you for this interesting presentation. So now in this brief session we have organized a presentation from Anwar from Ascora, a core EFPF partner, who will tell us a little bit more about the marketplace. The EFPF marketplace, as you've heard in various presentations, the applications and services being developed in the open calls are being exposed and offered through the EFPF marketplace. So here is an opportunity to learn a little bit more about the marketplace as it is and what is being planned for further enhancements in that area. So I give it to Anwar from Ascora.
Hello everyone. Can you hear me? Test, test, test. Good. So I was hoping, so I'm a technical person, I always love to have my laptop next to me, you never know when I need it. And I was hoping that today I could actually go slow with you and show you how we can use the marketplace, the integrated marketplace or the federated marketplace of EFPF to upload your assets to the platform. But unfortunately we can't plug the HDMI, so I have a video prepared and hopefully we can pause it, and whenever you have a question or so, please stop me and we can explain you more. So I'm Andrew Mabrouk, Research and Innovation Manager from Ascora. We are leading this marketplace task since the beginning of the project, but I joined the project from the beginning of 2019. So a lot of things that I discovered during this project has been improved, like extremely improved during the last 2.5 years, and I'm actually proud to show you the latest progress. So it's going to be a short presentation, but just to clarify what are we going to talk about in this half an hour, I will start with what is the EFPF federated marketplace, so like the features, the functionalities, the design itself, like the UI, what is available through the EFPF marketplace. We will talk here about also a bit about the what goes under the hood, so how does it work, how is it connected to the data spine, how is it retrieving products, and so on. But we're also going to talk about the already integrated marketplaces that we have, that you already probably know from vForce, Nimble, and SME cluster. Ongoing new integrations, and then a demo where we will see how you upload the assets and set up your Stripe account, and we finish with the conclusion. So, simply put, the EFPF marketplace provides a unified interface to multiple marketplaces from the EFPF ecosystem in one-stop shop approach. This is like what makes it really special and easy. So it's like a one-stop shop approach, basically like Google Shopping. If you know Google Shopping, you just Google there and it just get all the information from all the marketplaces and e-commerce website from the internet, basically. But here in the marketplace, the focus is more on the manufacturing sector, and every integrated marketplace that has been integrated within the federated marketplace publish or list their products in our catalog, and we can look and search and actually list those products in the portal itself. So this is the UI. Actually, no, this is the mock-up. This is where we started. I didn't do this, I found it, and I think it was in 2018 when the project just started, and the idea was just so simple that we want something really easy to use for users, customers, developers, manufacturing, tool providers to just connect, log in with their credentials, and actually find everything they need in one place. So here there is like a mention of some external marketplaces that they were planned to be integrated at that point. And from this mock-up, we got to this first implementation, let's say, of the integrated marketplace. As you can see, most of the main idea is to actually list those products in a way where you can see the name at least and the thumbnail, and that button will take you to the connected marketplace. So here we are listing the products, at least for this first prototype, and then you will be redirected to the external marketplace. And lately, this is the latest UI we got for the federated marketplace. A lot of feedback came from the EFF, so thanks to Usman and Dieter there, to actually get the feedback from the users, from you, the open call experimenters, and actually try to find something which in the end is a commercial product. People need to actually like it so they can use it. And also in terms of functionality and features, something that we try to get the feedback from the users, from the open call users, and try to improve it bit by bit. So regarding the functionality, so we are retrieving those products, just to explain you how it works in general. So the marketplace itself retrieves the product from those external marketplaces that we will see in the next slides, and try to not show which marketplace or which platform is like this product is coming from, but mainly make it simple to differentiate between a physical product, a service, and an application. And this is where you can see on top, like you can categorize or sort the products depending on the type of the product itself, of the offering. You can sort by name, you can search, so this is a federated search where you type the name of the product and you don't need to go marketplace by marketplace and look where can I find this, but actually if you know the product, it's like already, or the name of the product, you type it, or at least you type some keywords and you can get the result using the federated search. The Second, so like this is the search, the federated search that I just talked about. One thing that I want to mention here is, like, as I said, like in the end, the EFPF federated marketplace doesn't host those products, doesn't host the offering it's like themselves, but they actually, we retrieve them, and once a customer finds something that he actually interested to buy or just interested to know more like detailed about dependencies, prices, or whatever, we can he can just press on the visit button, and then he'll be redirected using his EFPF login credentials. So you log in once in the federated marketplace, and then you actually take that identity with you towards the other external marketplaces, and this is what we call the SSO. So it's basically just enabling SSO between those platforms. And once we like the user is registered in the EFPF ecosystem, that identity is being used to be redirected to the other external marketplaces. As a developer, so what we saw is mostly for customers, manufacturing users, and in the end, like marketplace customers who wants to search and find the offerings. For a developer, we also tried within the federated marketplace itself to allow the developer to, if there is a like he has a tool, he has like a physical product application, they can actually use the EFPF marketplace to upload this his offering. So like here you can see that we tried not to mention again like the names of the platforms, but basically make it simple for the developer. What do you have? Do you have a service? Do you have an application or a physical product? And depending on the type of the offering, he'll be redirected to the specific external marketplace. We will see later again like those 3 external marketplaces that we have. One of them is like to provide services. The other one, like vForce, is for the applications. Anything related to software, tools, installable executables, files, data, storage, and so on, is something that go to vForce. And physical products is Nimble, if you had the chance to actually see it. So just to summarize what I just said, so it provides a federated search functionality. Mainly, it's like a unified interface. The customer goes to will log into the portal. The first thing he will see is actually the marketplace now. This is actually another feedback from the EFF, that we always had the integrated marketplace within the portal. Now we took it out, and actually the user doesn't even need to log in. They can browse the offerings without even need to create an account or log in or provide anything. Which actually, it's like an Amazon. You open Amazon, you check what you need. If you actually like it, you log in, provide everything, and then you buy it. Product listing, checkout functionalities. This is also, like as I said, we provide that or we facilitate that, but the functionality itself is actually provided by the interlinked marketplaces. And those like the types of the user needs. So like the offerings that we actually support currently, we have software applications, IoT applications, sensors, hardware, and so basically physical products in general in Nimble platform, but also consultancy integration services that we will see later in the SME cluster. We start with the first, just like here I want to show you what is already provided or integrated within the EFPF federated marketplace. One of the, I think most of you knows, or I hope they already saw the vForce marketplace, and your tool is already there. And it's I forgot the name or the acronym vForce, from where does it come exactly, but I think it's a virtual factory for open system. I really don't know. Operating system. So, and has this like marketplace. Was one of the outcomes of the project, and basically had a bunch of apps, generic enablers, services, connector, drivers, which are still listed there, and they are actually ready to be sold and being used by any who's interested. And vForce Marketplace here is our, like for now in this current setup, is where we host most of our software application tools, which I saw yesterday, even in our, yesterday and today, most of the open call outcomes, the results, are either a web-based app, a WPF app, I think I also saw WPF app, an Android like mobile app, which probably is going to be an APK. So most of those tools, which are software, will be hosted in the vForce marketplace. Yeah, what else to say about the marketplace? I think that's mainly it. We come to the Nimble platform. Nimble platform is more for physical products. We have here, I think the Nimble platform itself, or the project, made this Nimble as a B2B platform for furniture. Like, if I can remember this correctly, Shannon is there, like telling me I did that was correct. And here the idea is integrating this platform or this marketplace is to provide the EFPF. Here is like the provider. So if you have anything physical, from hardware to furniture to machines, this is the marketplace that will host your offering and your product. And the third marketplace that we integrated is the SME cluster, which is, I would say, like a custom platform or custom marketplace where you can provide or list customized services, where it could be as simple as installing a sensor. It could be as complicated where you need to deploy a whole platform with all the licenses and so on. So it's like really customized and open to your service, and you can customize it wherever, however you see it. And I think some of the partners here already used it, or they already know this platform. Yeah, so customized services is for SME cluster. So that's basically it. So as we said, like we have vForce, Nimble, and SME cluster. Those are completely integrated. So like what you see in the current EFPF marketplace is being retrieved from those external third-party marketplaces. And so I don't want to go technically how does it work, but basically there is 3 steps. The first one, this SSO, what I talked about, enabling the SSO between the platforms, the EFPF platform and the external third-party platform. The service registry that I hope like in the data spine, there is the service registry that we are using to manage the APIs. Or the backend of our marketplace is using it to retrieve all the the products from the endpoints from those third-party marketplaces. And the last one, which is I think the more, let's say, unique selling point in this marketplace, and actually nobody even probably heard about it, is the accounting service that actually tracks the user interaction and also the transactions between the EFPF marketplace and the external one. Ongoing integration. So besides those 3, we are excited about 2 ongoing integrations. One is with ASI marketplace. So it's going to be like more than 57,000 standards listed in their marketplace, will be by the end of December also listed in the EFPF federated marketplace. And the same for ZDMP. So ZDMP is another one, like it's a project of mine. I'm also involved in this project. And it's like the whole project is towards zero defect manufacturing. And in this project, we have a couple of components and apps, enablers, connectors, sensors, Z-data, drivers. So a lot of manufacturing specific tools that will be listed in the EFPF federated marketplace by the mid of November, in order to be ready for this final event in what Usman just showed in Brussels. Yeah, that's maybe it. Like now I have the demo. As I said, I wish I had the HDMI, so there is no way. No? Okay, so we will see the video right now. I will try to explain you here before we start. What I will show now is how, as a developer, I have a tool called, I think I took an enabler or a connector. We will see later the name of the product. I'm a developer. I just created an account in EFPF ecosystem, and I want to publish it. So what are the steps? How can I achieve this through the marketplace and then through the dedicated external marketplace that will host my my app? That's right.
Does the video have sound?
No, I will talk. Yeah. The video was more a plan B if the the physical if the real demo didn't work. So we start with logging in. You already like the marketplace, it's a bit too fast, so you see like the upload button there. As I said, like every depends on the type of the offering you have, you'll be redirected to the market, like to the external marketplace. In our case, we have an application, so it's vForce. Here there will be this is a new window probably for most of you, where you need to connect your Stripe account or create your connected Stripe account in order to retrieve your earnings. So if there is any sales also, this is the way how you will get your money. I'm using here the test mode, just don't want to make a mess. I did this yesterday, so just as a plan B, as I said. You start with just telling a bit about your business. Here I said I'm a one-person company, so I don't have a lot of things, but you can also say it's a company. You just need to provide as extra just your TAV VAT number, so like for taxes. Personal details, legal name, date and birth, date of birth, all the I think just like the typical information that needs to be provided to Stripe, and probably for the invoicing later, home address, and so on. Everybody knows my birthday now, so I expect happy birthday mails. So the next step will be to provide the website. This is, as I said, this is the default fields required by Stripes. We didn't add anything extra, but we may add something if we require any further information. The next step, which is like the most important now, where you need to actually define your bank account, where you will receive the like the money. I used here like a test account, but it's basically just an IBAN and the right name. This is maybe for a further like Stripe requires you to actually confirm that it's actually you. You need to send a couple of documents, and that will be the last step to actually create this Stripe connected account and start receiving money. Yeah. So like with every sale you get, you can actually open your Stripe account from this window, and from there you can actually check the status of your sales. Now we go to the part where we will create a new product. We give it a name. So here we have German and English. There is an oncoming update, hopefully by the end of November or maybe the mid of November, where you select the language yourself. Description, describing the product itself. This will be shown on the product page in the vForce marketplace, and also in the federated EFPF marketplace. So this description is really important. Price, for now, this is still like we have euros, USD, and CHF. If there is any feedback, we are actually happy to implement them. Configuration, nothing to be changed. And the next step will be uploading the actual binary. So it's like in the end it's a zip file, but you can put inside a Docker file, like a Dockerize. You Dockerize app, your executable setup, your data sets, anything that you think it fits to be listed in the vForce marketplace. Here you set the version, the publish date. The version is needed so we can send notification to whoever buys the app if there is a new version available. And it depends how good is your internet. You need to wait until your app is actually uploaded. I think I want to say something about the zip file itself, but I think that's mainly it. Yeah, so like as I said, I saw yesterday that a lot of components have, we have a lot of types of outcomes from the open calls, WPF, web-based, probably Dockerized apps and APKs. And if you are not sure how you will or how can you upload your app to the to the V4 store, please contact me or anybody from the task team, also Alexander's. Yeah, that's mainly it. Your app is actually uploaded. It needs to be reviewed by the admin, the VForce admin. Here also the mail will be sent to the EFPF admin, and if everything is good, it's going to be published in both the marketplaces, the external one, but also the EFPF one. I wonder how much time do I still have? 45, okay. Yeah, we can go to the, so the last one, or I think it's the last one, yeah. So I want to here to definitely, yeah, appreciate the feedback from EFF. I mean, like what we saw in the last change we saw in the marketplace itself is something that came in the last period of the project, because now we actually understand how can we actually focus on those unique selling points. How can we retrieve the users or attract the user to the platform and actually give him what he needs, and in a really simple way. I like here a word from, I think it was from probably Dieter, like from the ecosystem to the ecosystem. So basically, we as a founding members, we know, or at least we have an idea what's missing there, and this is our way to yeah, like add to the industry and actually put all those decentralized or separate marketplaces in one unified interface. 3 or 4 things I would like to mention regarding some updates will come to the marketplace itself. One of them is actually to you have now or you will have in the next week, latest 2 weeks, the ability to add screenshots and custom thumbnails to your app. So I don't know if you already had your app in the VForce, you didn't have even the choice to change the thumbnail. This will change. The same thing for I think I thought like the translation, so the naming and the pricing. This will be more. It won't be I would say like hard coded, but it's gonna be your choice to actually select the languages and the currencies that you want to choose. And that's mainly it. The last one I would like to mention, I forgot which, I think Lortec or one of the open call partners yesterday, they mentioned about they were lacking support, or the marketplace doesn't really support the SaaS, so like software as a service, which I find it like a really good comment. And actually this is something, as the marketplace now will become the EFF marketplace, something that they can definitely emphasize and focus on and enhance, because that's actually the future in the end. Instead of will be like the perfect scenario if you buy the software and all the deployment, the containers, the roles, the creation, all of this is automated and can be easier for the EFF, and also for the client and the customer itself, and even for the developer, the tool provider. So thanks for whoever said that. I think you. Yeah, that's it. Any questions? Any comments? Yeah. No, I think it's not possible at all. But thanks. Thanks. Thank you. So I think that's it.
Thank you, Anwar. So I hope you found it interesting and learned a little bit more about the EFPF marketplace. We are really interested in sustaining this marketplace mechanism and further building on it. As you see that even with the end of the project approaching, we still have ambitious plans to integrate external marketplaces. We're working with partners and contacts in order to enhance the ecosystem and especially bring some industrial flavor into the mix. So please help us keep it alive and keep it running. If you are looking at marketplaces to expose your business offerings and solutions and services, please consider EFPF marketplace as an additional source, an additional interface to your target market. it is for free, so make use of it, and maybe we all will get something out of it. In the meantime, we are also interested in building on top of what we've already done. So in terms of new collaboration opportunities, marketplace is still a very vibrant and exciting component in platforms and in platform-centric projects. So we are interested in developing this further in future innovation and research innovation actions. And if you have any interesting ideas of how we can leverage the existing technologies and solution as building blocks of a new innovative solution, please get in touch with us, and we'll be happy to discuss further with you. So there are both opportunities on the business side to make use of this marketplace, and on the research innovation side to help us develop it further, or work with us to develop it further. It is owned and operated by EFF, as mentioned before. So EFF as a non-profit entity will be interested in working with you on joint ventures without having any kind of significant barriers of business and IPR aspects. So with that, I will like to close this first half of the day. We have some interesting discussions, and next up is a lunch break. We will use this opportunity not only to grab some lunch, but also discuss some of the things that have been presented now, and general networking. So a lunch break, and we'll put the timer back on the screen. We'll join you online and here in an hour's time. Thank you. Okay, so if everybody can come to the front, we're going to have a group photo taken. Find the best spot. Okay, as a common practice, the tallest at the back, the shortest at the front. Please figure out your size and organize accordingly. So everybody, ladies and gentlemen, people from Future Intelligence. Okay. I hope there's nobody outside. I'll have a quick look. Okay, you have 4 minutes to relax. And we'll start when the timer says 0. Okay, welcome back. So, I hope you had a good lunch, good break. We continue the series of open call presentations, and the first one to start is Digital System 4.0, and I give the stage to Nikolai from DS4.
Okay, thank you everyone. What I want to show you today is a very quick 5-minute introduction to the product, which was made possible by our collaboration with EFPF, and it's 5 minutes for that, and we have 10 minutes demonstration of the functionality of the product. Okay, so brief partner introduction. Digital Systems 4.0 is established in Plovdiv, Bulgaria in 2020. We are research-driven projects. We undertake research-driven projects in a very agile organizational structure. I've shown you a picture of Plovdiv there. As you can see, we have like 4 or 5 layers of history, starting from the Roman Stadium, going to contemporary, and it's the same with Digital Systems. We have only been established in 2020, but actually the first time we started working on projects with industrial companies and collaborative projects and research was in 1998, and first European project is in 2004. And we've been, experts from us have been working on the ideas behind what you see today since about that time, 2006, 2007, on this. So the objectives of the project is to add the functionality of semantic matchmaking to EFPF. We're using the federated service to receive companies and invitations to tenders. And we can, based on that information, we can create teams of companies who can together deliver what is required in the tender, and then they can bid for the tender. We can really make a difference for associations of small and medium enterprises, like the Upper Austrian Automotive Cluster, one of the organizations where we started kind of our ideas. We allow, but also big enterprises, we allow them to react to rapidly changing customer requirements and create teams which can deliver these change requirements. For example, scenarios, Lufthansa requires a specific configuration of Airbus cabin. Using our tool, Airbus could potentially bring together the teams of suppliers who can deliver this new configuration. Or starting the low level, the Association of Aerospace Manufacturers can also create a combination of SMEs in a team which can maybe deliver one component of this new cabin. We're using knowledge, we're using artificial intelligence, we're using a symbolic AI, not machine learning. Therefore, we are relying on knowledge about the application domain, and you see how we have mechanisms to build in and extend this knowledge. So in many ways, I'll call it a matchmaking plus, where you're creating the team, you're calculating how good the fit of these teams is together and how risky going with a particular team would be. Because of time limits, I would be happy to take questions at the end, or actually after that, whilst during the exhibition timing on this. So in terms of technical achievement, this is the way in which we fit into EFPF. We're developing 3 kind of components of our solution: the decomposition module, the semantic spine, which is enrichment of the federated search with semantic information and graphical user interface. And we have delivered all 3 components. We have experienced a little bit of a stumbling block, which was lack of detailed semantic information in EFPF. I mean, we knew that's going to be the case, but together with the team, so big thanks to Amber and Dietmar here, we managed to circumvent that, to overcome this, and to build in the processes and mechanisms allowing users to add information to what is missing. We also have released a secure API for EFPF, so EFPF partners can retrieve information from us. So it's actually working 2-way, and this is why we can enrich the information in semantic ways, and then we allow this to be retrieved by other EFPF services and modules. The demo is coming about now. You can see various versions of the screen, so it's automatically adjustable for mobile devices. It all works on the cloud. What you'll be seeing on the demo is the desktop version, but equally, I can show you after that the mobile version the Team Creator module. We are fully integrated with EFPF, and we have a single sign-on functionality, so you can either log in with a special account given to you by our team, or you can log in with the EFPF credentials into the tool. And now is the time for the demo. Thank you.
This is a short whirlwind tour through the functionality of Team Creator. Team Creator is a module attached to the EFPF ecosystem. We're using the federated search of the EFPF to retrieve information about companies registered with the EFPF, their capabilities, and also any business opportunities published on parts of the EFPF platform, and then to apply advanced AI matching between the business opportunities and the capabilities of the companies. This will create teams of companies together, satisfy the requirements of a business opportunity, and they could form a team which can bid for the business opportunity for the invitation. Team Creator being an EFPF module means that we can use a single sign-on on the right-hand side here, or we can use our own login system and functionality as on the screen's left side. After we pass through the information screen and click on the Access the Demo button, we can see the four major functional sections of Team Creator. The first section is for companies to be looking for a business opportunity through the open calls, which means open invitations to tender. The second section is to enter details about different companies which could then be considered for the open invitations to tender. The third section is for us to create new invitations to tender or to update already existing ones. And the fourth section is for people with an IT background to modify the existing product trees and existing categories of products in the system, enriching them with new products or categories as required. If we start with the first section, providing access to open calls, we could review current invitations to tender, providing business opportunities for our company in UX technology to participate. When we click on Laboratory Door Panel, Business Opportunity, you'll see on the left side here that we can break down the business opportunity of supplying door panels into two components, bifolded door and single blade door. We can select one of the two components, thus building our team incrementally, initially only addressing a part of the opportunity, or we can create a team capable of delivering the whole thing. Everything is flexible and adaptable to user needs. For example, we can nominate preferred partners to the teams, and teams comprising this partner will be pushed to the top of the alternatives that the AI algorithm is offering to the user. Here we select Bluetronics and click the button to make them up. We are now ready to search for teams which can together satisfy the requirements of that door panel business opportunity. There's a lot hidden behind the scenes in terms of the business opportunity and its requirements for certifications on the companies, capabilities which the composing company should have, etc., and matching these to the right combination of companies. Once we click on the Search for Teams button at the bottom right corner, the AI algorithm behind is doing its job and coming up with 4 different teams here, which you can see are presented in different panels along the top of the screen. Each team has a different number of companies with different roles, but for example, the 3 companies in Team 1 are together covering all the tasks involved in supplying the door panel. So what you can see in Team 1 is UX Tech, which is our company, assigned to plan and manage as well as integrate, design and source the materials for the door panel, whilst Bluetronics and Isoelectrics can actually design and develop their own components, which can then be integrated into the product by the UX Tech. So now we have a new team, which we can proceed to assign for this opportunity. We can also validate the newly proposed team or teams by A, checking if all the tasks are allocated to the roles, and B, if we have a task covered by the 2 roles. The AI check validates the teams that everything is okay, and we can proceed with sending an invitation email to the companies involved so that they can come together and create a response to the invitation to tender. Actually, because of confidentiality issues, we cannot send the email directly to the companies. At the moment, we are sending an email to an EFPF platform, which can then send it to the companies. Should Team Creator become a core service to the EFPF, we'll be able to send those emails and notifications to the participants directly, at least those of them who of course would like to be involved in this. So this was the first option about when we work with the second section of our tool, we can explore different companies registered on the system. We can see that some of them have information about the capabilities and about the regions where they operate, whilst others don't. Since we have 6,800 companies imported from the EFPF, we can search for a specific company. So let's have a look at CAT Limited. You can see they have information about their annual turnover and about target regions. Once you select CAT Limited, you can go into the details where we can see full details about their size, the certifications, the type of contracts they could be involved in, the materials they work in, industry classifications, and so on. We can also see information about the departments. Here we have a manufacturing and sales team. One's in Modena and the other's in Rome, both are in Italy. And when we click on capabilities, we can see what are the products which CT Limited can design and develop, and also plan and manage. We can of course add a new capability to a company. So let's say we'd like to add a new product which they can develop. When we click on the tree of available products, and when we expand the tree to search through different parts of this product, we'll very quickly figure out that actually the product we need here is not available already in the tree. In this case, we can click on the link at the bottom saying that the product I need is not listed in this product tree. What happens now is the system is telling us that in principle, any adaptation of the product tree needs to be done by someone who understands the principles of this product classification and the principles of categorization of different products, which we call IT specialist as a shorthand. So we will click OK here because we don't have the right authority to add a product to the tree. Then we need to cancel the planned modification of capabilities for CT Limited at this moment and discuss with the IT specialist our request for a new product, which can be implemented in section 4. The third section contains existing calls for tenders and allows us to modify and republish old calls for tenders or to create new ones. Maybe we can add a mirror on the laboratory door opportunity, change the date on the timeline, or alter the required capabilities of the companies which can successfully deliver this tender. Once we have saved the modified version, we can publish it, and then it will be available in the first section as a currently open call for the tenders. And then another company can pick it up and create a team which can respond to this new tender. Finally, the fourth section in Team Creator, which is products and categories, offers special functionality which allows a company to modify pre-existing knowledge about the way in which products and services break down into components and of the categories involved. There are two panels, products and categories, and each panel allows us to review the product or category tree in our system and to add a new product or a new category. Let us start with the product tree view, the first menu option in the products panel. As you can see, we have expanded the section on laboratory door modules, which we are trying to build at the moment. We have door panel 1 for the laboratory door module, which consists of these two components. This is what we saw as offered as the invitation to tender on the open calls for the tender section we reviewed at the start of this video. And we have a laboratory door handle and laboratory wash table as different parts, which helps us all together create an aircraft laboratory. But what we are seeking here is perhaps not listed on this tree. So once we have confirmed this is the case and we cannot find the products which our end users want to add into the tree, we can close this first menu option and select the second one, which allows us to enter the new product. In this case, the first thing we'll be asked to do by the system is to select the parent node for the tree to allow us to position the new products within this assembly. So let's say for the laboratory wash table, we want to create a new module. So we'll say that the laboratory wash table module 1 is the parent node or the name of the assembly, which will comprise our new module. And the category of the parent node is already specified as wash table module. We can click on next here, and that will take us to stage number 2 of the modification of the product tree, where we can either specify our own product name, say a table inset, or we can select our own product form, the EFPF data spine service, in which case we can simply search for table, and we can then select the table Bamba. We can then rename it internally to our system, and we can call it table from EFPF modules. So far, we have named our new product. We have said it's part of an assembly, which was the wash table in the laboratory, and then we can click on the next, and we can select the category which corresponds to this new product. Let us select the mixed color panel, capturing the category of our table inset. Of course, if we don't have the product category, we can go and create a new product category from the second panel. We can save our modifications, and now we have a modified product tree. If we open the list of available products and click on the laboratory wash module, we can see that table from EFPF is actually already a component of laboratory wash module 1. To recap, we have 4 major sections of functionality in our Team Creator module. The first one is allowing companies to work with open calls to tender. Having selected an invitation to tender, the companies can select a part of the product or service, the supply of which is the goal of the invitation to tender. We can then find a team or a combination of alternative teams where the companies within each team can come together and deliver that product or that service which is called for in the invitation to tender. This will help SMEs and associations of SMEs to form coalitions to help them win bigger contracts than the ones they would normally be able to. And this would also help Tier 1 suppliers and OEMs to provide visibility of the capabilities existing within the supply network and to allow them to quickly modify assemblies and create new modules and innovate reflecting changing requirements by airlines or by their major customers. The companies section is allowing us to work with different companies from the EFPF federated data search or those entered into the tool to cache it locally and to use it in the team's composition. We can invite the company, if they wish, to provide additional information to help with our matchmaking. Once we have acquired the additional information about the company, we store it into our database, and next time the company information is updated in the EFPF database, we could just sync the changes. We work in a similar way in a call for tenders, which has been pulled in from the EFPF using federated search, and we have our own product and category tree, which is aligned with the existing categorization and product tree within the EFPF. But again, we can enrich it with our own local information, which allows us to do more sophisticated reasoning about the company's capabilities, the materials, the standards, and all the other factors around a specific factory. This concludes our demo. Please do contact us for further information, and thank you for your attention.
Okay, so very quickly to wrap up impact achievements, we have disseminated. Thank you, Ingo. So we have disseminated what we have created at a number of EFPF events, Hanover Fair and the ILA in Berlin. It's also on the company website. There's a section on Team Creator, which you are invited to visit. There is a link to actual demo. You can request an account. You can request an account, or indeed you can use your own EFPF credentials to see the demo. And we have, of course, we have a leaflet, and I'll be here to talk with you about that. Exploitation plan related to EFPF outcomes, that at the moment we're considering the status of the service. Should it be a third-party service, or should we start to work with EFPF or with EFF rather, to raise it up as a status of core service, which will allow us to interact directly with the companies and acquire this additional information. We would benefit from this integration by, we believe, increased market exposure. We have planned for 6% penetration within the automotive and aerospace segments. And at the moment, we are really seeking a pilot install to raise the issues of trust and just so people can see how this has been implemented. So overall, participation in the Open Call has been very beneficial to us, allowing us to move our product from TRL 6 to TRL 8, I would estimate at this moment. And special thanks are due to Ingo, Amba, and Dietmar, who has worked with us very, very closely in the last 9 months to really put this off the ground. So thank you, and I look forward to continuing our collaboration.
The next in line is Digit Animal. Okay.
Well, so first of all, I would like to thank all the EFPF project for the opportunity to get our project done, and also to congratulate the rest of the Open Call partners for their great work and presentations. And well, my name is Diego Barona. I work for Digit Animal, and well, the title of our project is Digitization of the Meat Processing Chain from Farm to Fork. One thing that I have to highlight is that the name of the project itself starts with digitization, and it's not digitalization, as I will explain later on. And well, particularly this project is focused in the meat industry, so it's quite different from the rest of the projects that are mainly focusing on manufacturing domain. So, well, it is really interesting to see that the EFPF platform can be extensive for different use cases. So, well, first a brief introduction about the company, about DigitAnimal. And well, DigitAnimal is a small company that develops software and hardware solutions for the agri-food sector and mainly for the livestock sector. Our flagship product is this GPS tracker that you can see in this image. And well, this GPS tracker is mainly used for animals that are kept outdoors. So well, mainly for extensive systems in Spain where the livestock are kept outdoors for the majority of the time. And well, we also develop some different IoT devices as weight scale for feedlots and many other solutions. And well, the project overview is really to achieve a full traceability of beef production by creating a multi-agent platform for efficient data sharing in the meat production chain. And well, the main idea, just to give you a little bit of introduction and information about how this beef production works. As you can see in this picture, this is more or less an overview of the structure of beef production. So at the beginning, we have these breeding farms that are mainly composed of female cows and bulls, depending whether they make artificial insemination or not. And well, in these breeding farms, these female cows give birth to calves also that are sent to feedlots when they are more or less 7 to 8 months old. And well, later on they are sent to the feedlots where they are fed with concentrating feed until they reach a desired weight. And well, later on they are sent to the slaughterhouse and to the cutting plant where the desired different meat cuts are obtained from these animals. And well, at the end, these products are distributed to the customers. And well, also the farm to fork approach is a really important idea that the European Commission is trying to push forward. And well, the main idea behind this approach is to, let's say, to close the gap between the producers and the customers, so they get more information about all the production processes and well, to optimize all this flow of products. Well, so the main project objective, as I said before, is the digitization of the meat production and processing chain. And I say digitization because here in the beef production chain, we have the two main weak links that are in terms of digitalization, that are the slaughterhouse and the cutting plant. And usually, well, these agents do not have any, let's say, digital records of the processes that are being done. So that's why we are trying to change this process from analog to digital. And well, later on I will explain how we do that. And well, the specific objectives of the project, first of all, is the validation of a software solution based on the EFPF technologies on top of the hardware and IoT devices that we provide for the different agents of beef production. Also, we have one of the main goals for us was to test this farm to fork strategy that is really interesting for policy making in, for example, in Spain and also in Europe in general. And well, later on, just to develop a business model, as we see that this is a really interesting service, not only for farmers but also for the consumers, because they want to have more information increasingly about what is happening in meat production and also in general in food production. Just to mention a little bit about the technical achievements, here on the left you can see a really simple architecture of how this system works. And well, we are using IoT devices that we install on the animals themselves and also in the facilities, in the cutting plants. So well, we have this data from the GPS location, and also in the cutting plants we have this weight scale where different cuts are obtained, and then all these products can be labeled and weighted with a specific information. This is the main the main change that we have done in this process, because in the cutting plants they usually work manually with any digital let's say scale for tracking and having all the information about the orders that they have received and so on. And well, also in the picture on the right, you can see more information about the different relationships with entities and products that are contained in this solution. Well, here we have a video. Let's see. Well, it's only background music, so it doesn't matter. So here you can see more or less how it works, and it starts with an order that is placed by the farmer on the platform. So here, they have different products that the customer has required, and the quantity. So they integrate all this information in the platform in order for the cutting plants to obtain this information and to process all these orders. So it's really beneficial for them in order to also to optimize time because beforehand they made everything like manually. So it's really important for them to have this information. And really, we didn't want to include any information about the slaughterhouse, we don't want to ruin this nice event with strong images. So that's why. But this is more or less how this process works. And well, here as you can see, the operator in the cutting plant is weighing these products and including the information. And well, as you can see, all the information that has been collected is then included in the blockchain, as I will share later on, because we install a QR code in these products. And okay, I think the video is over. So if you want, you can scan this QR code that has information about the specific meat product. And the information unfortunately is in Spanish, because we have only included some agents, farmers and cutting plants. But you can see all the information about the origin of these products. So at the beginning you can see a map of where the farm is and where the animals have been kept. And then you also have information about the transportation steps between every agent, and also some information related to the different agents, as which slaughterhouse is being responsible for this product, and also which cutting plant. So you have a complete traceability of these products. And regarding the KPIs, this has been a really fruitful product for us, because we've been really thinking a lot of time before to implement this kind of solutions. And at the beginning, one of the KPIs was the integration of more than 3 agents. And as we have done within the project, we have integrated information from the farmers and also from the cutting plants, and we are able to provide all this information for the consumers. So we are already reaching this KPI. Also, we would like to have some positive evaluation by the users, and also with this QR code in the URL provided at the end of this this website, the user can let's say evaluate how they perceive this application, if it's useful, if they would like to have more information, and so on. So that's really positive for us. And unfortunately, we only work with 3 farmers and 1 cutting plant, but nevertheless, they all provided positive feedback for us. So that's pretty nice. Also, regarding the records included in in this tool. We have more than 1,800 QR codes scanned, so it's really positive evaluation for us. And in terms of optimizing these processes, this is something crucial that we've been aiming to do. It's the reduction in processing time that is really important, mainly for cutting plants. And we have achieved a 36% reduction due to the change from analog to digital. So the main topics that we address here is the optimization of orders, also the hardware solution, the weight scale that we provided. It's really, it simplifies the labeling of products, and also, it facilitates to reach lower food waste. That is also something crucial in the farm to fork initiative. And in regard to the farmers, it's also something crucial for them to see, let's say, tangible results for implementing these innovative solutions. And we have achieved a 16% increase in revenue due to stock control, because they can make a better organization from it. And they also can make different commercial promotions in order to, let's say, dispatch some products that maybe they have less time for processing it, and so on, and also for consumer acceptance, because you can already see from your perspective that is something positive for the consumers to have all this increased traceability of the products. And related to the impact achievements in the dissemination results, we have made several publications in our social media, and also in our own blog in the Animal website. So that's the main activities that we have carried out. But also we have some direct communication with farmers that are the, let's say, the main target of this solution. So we've been trying to disseminate the benefits, the potential implementation of these tools for them. So that's been really the dissemination results that we have carried out throughout the project. And in relation with the exploitation plan, we have created this product sheet from the service that we have created. But something that is really important for us, and we are really thinking a lot about this, is one main problem that we have in the livestock sector is the question that we always have is who pays for this? For example, the farmers are not really willing to pay for innovative solutions unless they see a really profound benefit for them. So maybe we have to find a way. For example, the easy way to get this done would be to increase the price of the product, but also the cutting plants are involved in this process. So we have to find a way, let's say, to share the cost of this service in order to provide this information. But we really see that all the agents involved have really evaluated it in a good way. So that's the first step for us, that it's really important. As conclusions, the overall experience, it was really positive. For us, mainly related to the data spine, we would like to have simplified user management as such, and only related with the EFPF platform. It would be really useful to monitor the status of the different services available, because we saw that we had a few problems with the availability, for example, of the blockchain module, and also to have more detailed information on the long-term sustainability of these services, because for us it's really important, and we implemented this service in a commercial setting, so it's really important for us to know whether we can go on with this process, because otherwise we have to migrate this service to another, let's say, architecture or kind of system. So it would be really nice to have this information. And I think that's all for the moment. So thank you very much for your attention.
The next presentation is from Simterra. So I think Simterra participants could not be here physically, but they provided virtual. They will join over Teams, so we'll try to connect them on Teams and broadcast it here.
Hello, I think you can hear me.
Hello, yes, we can hear you.
Yeah, I start now. Hello to everyone. Thanks for the speaking time. I will give you some information about our type 2 experiments, so the validation project that we validated EFPF services on a continuous galvanization line. Let me give you a little bit information about the experimentals. First, Simterra. Simterra's main offering to the market is Fabric solution, which has at one hand side solutions for factories, other hand it gives solutions to machinery industry. So for factories, the main thing of Fabrics do is to have a digital shadow of the factories, and for machinery builders, OEM producers, the main idea is to offer a local platform that machine industry can offer industrial IoT and AI-driven digital services. So, and all these two offerings are given to the clients over these 4 products indeed. And today you will see that demo is built on the integration of EFPF services to Fabrics Insight product. So, and about Borçelik, it is the testbed provider indeed. Borçelik is 23rd largest industrial establishment of Turkey and biggest galvanized steel producer of Turkey. It is a joint venture of Borsan Holding and ArcelorMittal, and it has around more than 1,000 people working for the company. So the main project is indeed made on the galvanizing line of the Borçelik, which has equipped with condition monitoring sensors. The line that you see in here on the left indeed has 43 different pumps and fans on the system, and all these 43 pump and fans are equipped with condition monitoring sensors, and at total there are 332 data tags are coming from every pump and fan. So the idea was to utilize this sensor data and optimize the maintenance activities of Borçelik. So how to do it? Real-time analysis of the sensorial data. Firstly, to identify anomalies. Secondly, to calculate the remaining lifetime for each equipment. So that was the idea. And under this main idea, the objective was indeed to increase the uptime of this line. And with anomaly detection services, we plan to give better visibility, because if imagine you have that much equipment and that much data text, it is not possible to real-time analysis of it by the maintenance workers. So we need a anomaly detection service which is checking the data, and if something is going wrong, not as usual as before, so a notification should be sent. Other is better planning with remaining lifetime calculator, so how much time left to have the next maintenance. So that was the thing. In this case, indeed, we use factory connector, EFPF security service, data spine modules, data workflow configuration, EFPF anomaly detection service. When we wrote the project, we thought that analytics tools can be integrated with Open API, but it was not the case. So we didn't integrate it. We couldn't integrate it to the architecture, but we also tested it manually and reported the findings about this service as well. So mainly these are the services that we use under this architecture. So as I showed you, there were equipment connected and their data was coming to data spine, and then it was analyzed over the anomaly detection tool, and then the outputs were going to the dashboard that you will see in the demo. In the scope of the project, there was also one step or a dissemination activity to compare EFPF anomaly detection service with AWS lookout for equipment anomaly detection service. So in that sense, we had also an integration with native cloud service as well, and received the data and sent back to EFPF architecture. So there were 7 KPIs that at the beginning of project. So we completed almost all. So we connected 6 different equipments. We connected 2 different sensors. We validate anomaly detection service. We put as 6 models, but we made more than 6 indeed for 14 different equipment. We run it. And we, as a KPI, we said we will test with 50 time series data sets. You will see on the demo, we also tested it over 175 time series data set. We were planning to integrate the solution to the digital maintenance management system of the board check, but this is partially completed because the anomaly service MQTT subscription was not working. So that part just missed, but the other integrations are done. So besides this, as I told you, we also, at the beginning, we didn't choose the native cloud service. So in the progress of the project, we decided on AWS, and we also made this integration as well. So that kind of integration also tested. And we also decided as a KPI to make a webinar that is presenting benchmarking of the EFPF service with native cloud service, as I said, and that has been also done. So that were the KPIs on the thing. There was a deviation from work plan that instead of webinar, we switched to a video because there were some problems coming from data coming from EFPF services. So to reduce the technical risks at that moment, so we did it with a video in the context of webinar indeed. So as a technical achievement, I can show you the product. So we integrated the system here. This is the production line indeed. We integrated, so all data and different dashboards, from different dashboards you can see the data coming. So as I told you, over 175 tags has been, time series has been integrated to the system. And in here you will see different equipments indeed and different time series, and the anomaly outputs are also generated in here. And as you see, when there are anomalies, it is going to also maintenance service of the maintenance system of the board chelic. Other thing is, indeed, we integrated these anomaly services to our manufacturing process model library that I will mention you more in detail. And these right now, not only board chelic, but all these anomaly detection services are open to all clients of FabMetrics. So this is the product. Then let's continue with the presentation. let's continue with the dissemination results. So as I mentioned, we made this video, and the video is right now reachable on Fabmetrics YouTube channel, and half an hour video, which is giving an overview of the anomaly detection service of EFPF architecture and our benchmarking results there. Besides this, of course, we also mentioned on our website about this EFPF activities on our websites at Newspark. During the experiment time, we have been also attended at 2 different conferences. At Borçelik site, Saygın Kaçar mentioned about EFPF system at TEMSCON conference, and at my Sintara site, I was giving a speech around the artificial intelligence and database process management on the industrial facilities. So on that also, I mentioned about EFPF anomaly detection service under the predictive maintenance part of my presentation. What is the impact when the anomaly service is ready to use? We already integrated it, but we just opened it to Borçelik. When the service is stable, we will open this service to all of our clients. And in the idea in our manufacturing process model library is like that. In vertically, you see our different AI models indeed. And on these boxes, these are AI agents that are configured by the end user. So when an end user configure an AI agent, which is using a AI model and some data set, we calculate a cost for them. And then if they approve this cost, then our product is a SaaS system. We add this AI service cost to their invoice as well. So in that way, we will be able to exploit the anomaly detection service. This is all from our side. I want to thank also all EFPF community and our supervisor Shannon in the course of the project, also Alexander's support and all other people while we were validating the services, all the developers. Thanks for your time.
From Capgemini.
Hello. Well, my name is Carlos Mendez. I am Innovation Technology Manager from Capgemini, Spain. We are 400,000 employees about all around the globe. Believe me, I don't know all of them. I'm going to present, this is the page. Okay, I'm going to present the integration that we have made for our platform Exist with the EFPF environment. Okay, but a bit of context first. I suppose that most of you imagine that we are at the edge of a new industry revolution. You know that probably COVID and Ukraine war and so on has boosted or raised some problems, that supply chain delays, shortage of materials, the demand, a lot of things, okay? That highlighted the need to be more flexible and sustainable and resilient, okay, in the terms of the industrial sector. So from the very beginning, you know, we have passed a lot of industrial revolutions. Now we are in the Industry 4.01, which is more related to the data and the connectivity. And now we are in the beginning of the Industry 5.0. What does it mean? Industry 4.0 has focused, as I said, in smart manufacturing, in process automation, and on increasing the productivity and the performance in the production. But Industry 5.0 will focus more on customization. and the flexibility to be able to adapt our production methods to the demand. How we can do that? Well, one of the things that probably is very important is to put the user in the center of all of this equation. Okay. Thanks to some technologies, all of this, the CATs, the key-enabled technologies, we will be able to do that. Some like artificial intelligence, edge computing, 5G, big data, cobots, and blockchain, of course. We will bring us a lot of technologies. Well, putting all together, we will be able to achieve these objectives. The human-centric industry. Okay. It's very important to empower the user in that sense, and it's very important, and it's a labor to all of us to do that, okay? To put the user in the center. Why? To use the machines as collaboration machines, not as competitors. It's very important to see this in this revolution. Also, the operators has to be assisted for intelligent agents that will help us in that process. And also, we will give the machinery artificial intelligence capabilities. Okay. So this is Exist. Exist is a software that we created to facilitate the creation of collaborative environments for creating Industry 5.0 applications. So we offer connectivity between users with different kind of HMIs, human devices, and machines. There is a lot of features, but the best of all is that it's integrated with the EFPF platform. Okay, we are based on an open API. It's extensible, it's scalable, it's designed to live natively in the cloud or in the edge. So it's very easy to distribute all the information all around the globe and interconnect as you wish. So there are some benefits in the connectivity with Exist and EFPF. First of all, we are able to offer some services and some SDKs to provide artificial intelligence, distributed artificial intelligence to some devices, some IoT devices. We are able to create digital twins for robots and to put it in this collaborative space. And we are able to give some tools to support the so-called name industrial metaverse that is trademarked, by the way, but it's the word that everyone is now using for talking about collaboration or around operators in different places and distributed operators. Okay, and by the other hand, we have took benefit from EFPF in two main ways. From one side, we're using all the key cloak or the authentication from both points of views. For the point of view of the user that is using the virtual reality glasses, augmented reality glasses, mobile phones, whatever, and for the backend as itself. So Exist as itself is integrated directly with the EFPF. So we can give permissions to one node, for example, that is running in one place, or to revoke it. All of this on real time. Okay. And by the other hand, we are using the data spine for publishing and consuming data for all of these digital twins and all of the artificial intelligence services that we are deploying. This is a small overview of the point of view of the authentication. So as I mentioned, we used two different approaches. One is for all of the nodes that we have distributed in the cloud or in the edge. We're using a tokenized method for authentication. So Exist every time that a new node, for example, for natural language understanding goes up, it authenticates with Keycloak. If he has the rights to do it, it goes up. Otherwise, he can't run. And for the point of view of the user can enter from two different ways. One is by providing, it's not in the graph, but providing the username and the password. But sometimes, and you will see in the demo after that at the end of the room, okay, with the virtual reality glasses, it's not so easy to write in the glasses, so sometimes it's better to have a pre-shared key, for example, like reading a QR code or something like that, and this QR code authenticates. Okay? But both systems are supported in the environment. And the other part that we have integrated is the part of the data spine. Okay? Here we have used both approaches because we have implemented two different POCs. One of these, we are using directly the data transform using NiFi, and the other one we are using AMQP to publish and consume on real time the different topics. So as I mentioned, we have developed two different use cases. Okay? First one is expert support digital twin, and the second one is digital assistance using a projector. Okay? For the collaboration between human machines and humans, what we are offering is a set of microservices that is integrated on the data spine. For teleperception, that means that any operator that is connected to EFPF will be able to receive the data from the point of view of a robot or a remote agent, okay, on real time, thanks to the integration of their sensors into the platform. And teleoperation, this is bidirectional, so any operator with the proper rights will be able to control this robot or this agent remotely in an advanced way, you know, for example, by touching in the air. That is one of the things that we have implemented to test it. And as I said, industrial metaverse, that, you know, is the word should sound a bit funny, but has sense, okay, in the way that we are thinking. There are two ways of thinking about metaverse. One is the typical that is in the, you know, in the B2C world, that is everything is distributed and, you know, the avatars will buy something using blockchain and so on, okay? But from the point of view of the industrial environment, it's more related to the way of how can I represent myself as an avatar in a seamless world with other operators that maybe are avatars, maybe are robots, maybe are a mix of things, and how I can move naturally and operate with the things in the environment in a natural way. This is one of the key points in the metaverse environment. Okay? By providing training, by providing real-time support, that will depend about the use case in any case. Okay? And of course, that will give us the possibility of interconnect with other avatars, but operate with machines, using the digital twins that will be in this virtual environment as well, in this metaverse. And of course, share information, models, or whatever we want from different locations on real time that will enrich the experience or help the operators to do things. In other terms, to put the user in the center of the industry when they are performing some task or doing some things or trying to learn new operations. Okay. As I said, we have created two use cases to validate this. The first one, we call it augmented assistance, is how an expert using virtual reality glasses from a remote location, that today will be Vienna. So when you're trying, you will be the remote expert. I suppose that most of you can control a robot. So you have to try it, okay? And an operator in a factory in front of the real robot using augmented reality glasses that is asking for support because he doesn't know how to do a certain operation. And to do that, apart for controlling the digital twin, we have integrated some AI services. One is for following a bottle or an object in the environment, but everything is deployed in the cloud and everything is EFPF connected. And we are using voice over IP and we are using automatic translation. And this is another node that is deployed on the edge. So anyone from a third party can consume these services as well. Okay, so there is a small video here. Yeah, sound if possible. So this is the point of view of the operator in front of the robot. This is what really he sees with the glasses. He selects an avatar, as I mentioned, as a representation of himself in this world. And this is the panel. He pinches the panel. And you can see the robot is highlighted. That's why there is a digital twin over the robot overlaid. So every time the user touches in the air, the real robot and the virtual one goes to the same place. You will see later on that all of this information is coming from EFPF. Okay? Now, he's asking for some assistance because he doesn't know how to perform a certain operation. And the point of view in the frame above, this is the remote expert connected with virtual reality. So the real one sees an hologram of the other one.
Can you help me?
And the virtual one sees an avatar of the other. Okay? And both sees the digital twin of the robot.
And now try it yourself. Okay, it works. And now, how can I make the robot arm to follow objects?
And this is for following objects. So we activate the following objects capabilities. So the camera that is there is sending information frame to frame to a service in the cloud. The cloud is reading the bottle position and sending the information to the robot to go to this position. Everything using EFPF. Okay? So all these topics is readable and you can see later on.
It's working. And now, how can I power up the robot arm? Sorry, I didn't understand. Can you translate it? Yeah.
And the same for real-time translation. Okay. So here, for example, you can...
How can I power off the robot?
This information goes to another node, it's translated, we create the sound wave, and the sound wave goes to the other user that is connected.
You must press the red button on the tablet.
Okay, I'll try.
Okay. I'm going to stop here and go to the next slide because otherwise I will run out of time. Okay. So this is more or less the architecture for this use case. As you can see, all the exist nodes is connected through EFPF except the part of the collaboration from the VR and the AR. Okay? But all the industrial part comes from a EFPF. So for us, it's very important this. It's a high achievement because let us focus on users and not focus on industrial robots and so on. Even for authentication, even for industrial protocols, whatever. Okay. And the second use case is for helping an operator in a laboratory. To do that, we are not using virtual reality glasses because you are in a laboratory. You have to be as free as possible. So what we have made here is to put a projector on the top and calibrate on the table. And we have a lot of assets in the table, like thing to weight things. I don't know, scale and scale. Okay, you have several things that is integrated with EFPF as well, like object detection for detecting your hand, detecting the where are the places in the table. Okay, so you put the video. For this, the architecture is slightly different, but here we have something very important, that is, thanks to this approach, we are able to create a digital twin of the whole process. Okay? So you can imagine the table on the reality, but you can imagine the table in another place, simulating all the information that is projected in the table as well. Okay? Okay. And first of all, I want to thank Nick for the support. Very appreciated, in fact, and I have to say that we are very happy about the results of the project, and the system was surprisingly fast. We were expecting less performance at the very beginning because, you know, all the metaverse things are very difficult to implement. For us was a really good surprise that how EFPF has performed, and we are very happy about that. So thank you very much.
Now we know our system was breaking in the earlier part of that year because you were pushing this real-time streaming data, you know, on our system, on our test system. Okay, so the last presentation from ceramic.
Hello, very nice to be here. I think everyone needs a healthy dose of material science at the end of this very digitally heavy conference. So I will be presenting our project called Ceramics 4.0, and our aim is basically adapting the processing of ceramics to Industry 4.0. I am a faculty member of Material Science and Engineering at Sabancı University, and my co-PI was a mechanical engineer. And we are based in a university, so this is a non-profit organization. And I will also explain our business plan that's pertaining to Ceramics 4.0 as well, with keeping this in mind. Throughout the presentation, I will ask you to keep in mind these two keywords. One is carbon tax, and the other is supply chain problem. A little bit of material science 101 here. So, three main parts of materials, right? Metals, polymers, and ceramics. You are all familiar with it. If you are drinking your coffee in a mug, you are being exposed to a ceramic first thing in the morning. With metals, for instance, how we process them. You have seen it in movies, especially, for instance, Lord of the Rings and such, how metals are processed. You melt the metal, you pour it somewhere, it takes the shape of it and such. Then you can further shape it afterwards as well. But for ceramics, you have to start with particles. And these particles, think about of chalk. Remember you wrote, I think our age group is proper to remember the chalk-based boards. Remember that chalk. Chalk is a part of a ceramic particle that you can consolidate and such in order to form a solid body. The last picture is actually representing the sintering process, the process that we carry out at very high temperatures. So you do this at 1500 or so, depending on the material that you have. Then these particles are merged into each other, okay? And then, of course, you have a very hard body. Think about the mug, right? So, but ceramics have all these wonderful properties which cannot be matched with other materials: high strength, high durability, resistance to chemicals, like, you know, resistance to temperature and such. All these properties that we love about ceramics is really problematic once we try to process them. So many people are doing the ceramics processing at the end of the sintering process on the right-hand side of this graph. What we are doing, like throughout this project and else, is actually we are doing the processing here, close to me. That is called green machining. Machining the ceramic when it is still soft. I think we all played with clay when we were small, like. So we are doing the processing at this stage, not at the very hard stage. Let's keep that in mind. And then let's also keep that in mind. Let's go back to the carbon tax argument. Once you do the processing, after you spend all this energy to consolidate that ceramic at 1500, if it breaks during processing, you lose it, right? So all of the ceramics companies are trying to reduce the amount of their waste. And upon our interaction, that number is up to 35%. 35% of the ceramics are going down the drain. It's very hard processing to retain them back. So, and if you are doing the processing at there, then you have to work with very hard tools like diamond, silicon carbide and such, so you suffer from tool wear. And again, as I was saying, you suffer from brittleness. And ceramics are severely underestimated in that sense. We are processing the ceramics with methods that are designed for metals. So that is one of the problems as well. And when I was writing this project and also other projects, I constantly write about digitalization of ceramics processing, custom-based production, and all the keywords that we present in Industry 4.0, right? We have heard a lot about this today and yesterday. They only return results from tile producing, right? You can obviously check and change your bathroom tile design and such, but then once it comes to advanced ceramics, we don't have it, right? By advanced ceramics, you are hearing it more and more every day, with also especially extreme materials, space applications, because other than ceramics, no one can deliver that kind of thermal management. Everything will burn. You need ceramics. So, and then we need, of course, customized production, also in low numbers. That is very important. I was invited to speak at a British Ceramics Confederation meeting. Remember 5 years ago, we were talking about all globalization, everyone should produce what they can produce best, we will exchange and such. We have seen that during Corona, it didn't work, right? So we suffered from all this supply chain management. So in that UK meeting, they were really afraid of carbon tax, one thing. And the second was, can we produce things locally? Can we just, like, if I would like to only produce like 1,000 of this thing, which I cannot get from Taiwan next month, can I do this at home? So what we are doing in this project is enabling, especially the small companies, to be able to develop their own digitalized processes for the high-tech applications of advanced ceramics. So let's see. Or enabling technology is this. We can, like I'm a materials engineer, and this is, or we have 4 international patents on this, 5th one is pending. We can make play-dohs of ceramics. So you remember again the clay you played with. We have it for clay for structural reasons. We don't have it for alumina. We don't have it for zirconia. We don't have it for magnesium oxide. So what we are doing is play-dohs of ceramics that can be readily shaped so easily. Okay? So that is my bit. And of course, once you have this Play-Doh that you can do all this magical stuff with, what we do in this project is basically create a model-based approach and then standardize everything, every bit of it, I mean everything, in order to make this process predictable for people who are non-experts, right? That is what we would like to do. We would like to democratize design. We would like to enable people to be able to produce low amounts of batches without much knowledge or any capital equipment. Investment, additional one, right? So what we do is, first of all, we have this thing called toolpath geometrical analysis, right? Imagine that you have this ceramic dough. You initially brought it into a standard shape or not, but then you upload it to the system, the final shape that you would like to produce. So what we do in this project is we generate the toolpath for you. So you can directly get this information and upload it into your CNC machine or whatever machine that you are going to use in order to do this processing. We give you the toolpath. You see this thing called shrinkage information here. This is a materials parameter. This is what we mean by shrinkage. So imagine that these consolidated particles, once you heat them up in the end in order to have your final object, the materials shrink in size. Okay, so this is an experimental parameter that one needs to feed into the system, and then we have done that in the project as well. So we basically give people the cutting forces, and then we give them a simulation such that they could actually pick up their process parameters and they can immediately use without prior knowledge. And what I mean by ceramic processing, so that you actually see what is going on, we worked on 2 different processes. One of them is 3-axis mechanical milling, and the other one is turning. I would like to bring your attention to the chip formation on the right-hand image. You see the chip is forming as if you are cutting a metal. So this is very crucial in our system because there are, of course, we are not the only ones who is doing the machining at the green state, right? There are other people. But what they are doing compacts of powders. Imagine the chalk powder. You squeeze it in between two metal plates, apply a lot of pressure so that that powder is squeezed. But then once you do it, and then once you try to machine it, it basically chips off from the surface. It does not create this nice chip formation that we can base our analysis, right? So that is what I mean by, we have a very enabling technology in terms of materials to attack this problem. So these two, and one proper example, and one we did intentionally to show that what is not proper for this kind of thing. So on the left-hand side, you see this proper chip formation, and this is mechanical milling, right? And on the right-hand side, you see all this breaking of the surface and such. So if you do not have a good starting material, you end up with this improper chip formation, which also will prevent you from doing the predictive analysis or having a good final product. So we are aiming at this structure with proper cutting forces and such, all repeatable and such. So that is what we have done. So this is our toolpath generation and modification module. I will also show you in the app screen that you first of all start with your final object. So you will tell us what is the final object will look like. Of course, I'm not going to claim that this is all applicable to all types of shapes and standards. So if you have a very high aspect ratio object, obviously that is not going to work. We are at this stage, we are very working on isostatic shapes, more or less symmetrical and such. So our system or volumetric module basically tells you, you enter your tool shape, tool size, tool length, so whatever that you have at home, and then we basically generate a toolpath for you, which is directly applicable to your machine. So we also give you information about the surface roughness. We also give you information about offset and such. And then these are all one very important thing here. So why we would like to work with EFPF is this. We do the simulation, but we also do the experimental part, really in the lab, measuring things and then handling things by hand. So the experimental part feeds into the simulation, and simulation sheds light onto the experimental part. And eventually, what we are doing at EFPF is we will ask people to upload their own, machining data so that the system will keep learning from this updated results on the EFPF platform. That is why we submitted to this program actually to have an open access and this machine learning for the process itself. So yes, it tells you about the forces, their distributions and such, and all of the output is actually on the spreadsheet format, which is easily streamable and such, and adaptable to the databases. So we give at the end of this simulation lots of information about how to carry out this process without any surprises. So in the mobile app, although eventually we decided that a web-based system is going to work better, but then for the sake of the project, for the mobile app, you first go to the database of materials, which will be in EFPF platform, such that you see all these advanced materials. We propose this project for yttrium stabilized zirconia, but we have also done aluminum oxide and magnesium oxide as well. So you go there, you get the information from the website on your materials properties. And then afterwards, you upload your final shape such that we are going to give you a toolpath. But with the shrinkage, we of course modify the image that you submitted into the system because it needs to be bigger so that it will shrink once it gets into the oven. So it shows you the results of the simulation. And at the end of the simulation, you can either use directly the file, or you can actually enter your parameters manually to your own equipment, and you can see the simulation results for your own product. And you do the processing, you do the process and such. And then in the end, again, as I was saying, we would like people to upload their own results so that the community can get bigger and such. Yes. And then the results will look like, for instance, you will see the cutting forces and such in your system, what kind of forces that you should be using, what kind of roughness that you are going to end up with. And we have also done this laser cutting and such, which wasn't promised in the proposal, but then we knew we could do it. And we are really grateful because EFPF gave us an extremely important jump start to basically state ourselves as one of the leaders in this green machining of ceramics. And one thing that we promised is, the carbon tax issue to start with. We have collected all of the powder, all of the waste powder, or the wastage materials, and then feed them back into the system. So we created a no material leak process flow because we can actually utilize all of the powder or broken objects, broken in terms of at the green state, into the system, process them again, and then can still machine those materials. So this is extremely important for materials processing. And the thing that is currently missing, which we didn't promise to start with, is the surface characterization and roughness characterization of these objects that we created with the recycled materials. That is to come later on. So as I was saying, I'm an academic, and my co-PI is also an academic. We disseminated the results in academic setups and in meetings with industry. And we have submitted an EIC Pathfinder that we are going to hear hopefully in 2 weeks. We have received this smaller transforming foundation industrial result, like only 30,000 British pounds for 3 months, but it is also a good start. We will continue working on this project, and we are submitting to Royce Institute this Friday actually. So we are aggressively developing academic funding towards this project. And what is going on in terms of business development? I am an intense person, so to speak. I harass people in LinkedIn. So what I do is I wrote to the CEOs of the ceramics processing companies and tell them that their process needs improvement and such, and then why don't we start a discussion. It was like that a year ago, but in the last 2-3 months, people are coming to me, which means that our system, our posts and our dissemination results are picking up their wind. And so harassment is business exploitation, one tactic. And then the second one is 5G, right? Europe is not doing well. I don't know why. US is collaborating with Japan. Of course, Taiwan and China are doing their own thing. Europe is not doing anything. A lot of chips are being used in Europe. Somehow, we do not do the production. And as you might have seen, this is a method that is very prone to produce chips or 5G components, which are going to be needing much more infrastructure than the previous Gs, right? So we need to produce. So what we are doing is we are picking up technically important products. One of them, you are seeing the simulation and actually the production, the electric resonator antennas. So what we are doing, we can produce those things by a cookie cutter. I am not kidding. With a cookie cutter, I can produce electronic parts. And what we are saying is, this is this is the production that we do. Let us explain this in an academic publication. As well, let us report the performance so you see which one is easier or which one has the higher performance compared to all these other companies like Kyocera, Shimatsu and such. Let's see how the performance goes on. And then we are frequently doing these newsletters on our publications. So we know that the industry is not going to use a fine comb to go through or academic publications that we report everything, but then we are communicating the gist of what we do in terms of this industrial dissemination. So far it is going very nicely, and one of my personal aims is to really work on sustainability and such. And I really think that telling the companies, okay, you have to increase your efficiency, good, consultancy and such, 2%, 3%, great, all are improvements, but it has to start at the materials level without actually doing the hardcore manufacturing. All the efforts of digitalization is very questionable to me, but of course I am biased because I am a materials and manufacturing person. So thank you very much for listening, and I will be around to answer any questions. And I think since this is the last talk, maybe I can stay here a little bit and answer the questions if you have any. Thank you. All right, I'm around. Please do.
Okay, so keeping up with the program, so this was the end of the open call presentation. So thank you very much for your participation and very, yeah, please. Thank you. So we will be following it up, of course, with the, we need to provide you some feedback. Several EFPF partners took some notes, and we learned, from your experiments. Of course, not all the partners were looking at all the experiments, but now it's become more visible. So hopefully we'll be back to you with some comments, some suggestions, some discussion points. So this will be the next step. Today we conclude with the final presentation from our host, Carl Grun, who's the director of ASI, and will tell us a little bit more about the standardization work overall that he is doing, the ASI is doing, and what they are doing in terms of standardization within the EFPF project. So the final presentation from Carl.
Thanks, Usman. So I must say, wow, amazing. What I've heard from this open call pitch is great. So it's very hard to start with what some of you might perceive as the most boring issue of today's presentation, standardization. Oh my God. So, but yes, but I try to make it a little bit not so boring. And I will today focus in my brief talk about the importance of standardization in creating a collaborative digital ecosystem, and what we in EFPF are doing to make life easier for you in terms of to identify which standards are applicable for you, which standards are there, how you can use them, and especially what are the opportunities for you when making use of the EFPF platform. So when we speak about industrial ecosystem, what is an industrial ecosystem? It's of course not an island where one manufacturer is sitting and producing products, services, or whatever for him or herself, but there is collaboration, cooperation, co-creation. So it's more than one player, and so it can encompass all players, but not only in the supply chain, downstream, upstream, but the whole value chain, yeah? Upstream, downstream, upstream, etc., etc. And it's from small companies to multinational companies, it's from academia to research to market, and so on and so on. And as you can imagine, there are a lot of interlinkages, interdependencies between all these players, constitutes of an ecosystem. And that, you can see here also a kind of a chart where this industrial ecosystem is, yes, briefly described. But when we speak about speaking to each other, sharing information, data, that brings us to the next issue, which is about interoperability. Because, for example, Usman, when we are speaking, we have to agree on the language, on the meaning, on the context, and of course also how we speak to each other. Do we use here the air where I say something and then use the air to transmit my voice to your ears? Or because there's a vacuum between us, so you can't understand me, I have to use something else. And there was a study performed by the European Commission in 2020, and the final result was presented in 2021, where they have identified the main barriers for realizing operating industrial ecosystems. And one of these main barriers is the lack of interoperability, of data sharing, and that means also of standardization in terms of data exchange to realize interoperability. When we speak about interoperability, again, it's a question of definition, and here in standardization we are very good in defining terms. We have to realize there are different types of interoperability. I have already tried to explain to you what is interoperability about. It's to agree on how we communicate. For example, which system we will reuse, what's the data language, the architecture of the data. For example, when I speak to you, I use now English. Sorry, it's an Austrian English. Yeah? But how is the sentence built, yeah? That you can understand it? And of course, the context of in the data. So a kind of dictionary and predefined terms and with definitions. So here are different types of interoperability. And that's also the reason why we have so many standards. And 2 slides before, there was the perception that there's a lack of interoperability because a lack of standards. The contrary is true. We have hundreds of standards, but dealing with different aspects of interoperability, of data exchange. What we have done for you, for the ecosystem, we have made a screening of the standards available, those already published, those are under elaboration. And this you can also see in the next slide then. We have identified with which aspect of interoperability each standard is dealing. So we have here, for example, MQTT. We have seen that in the last presentation. Wonderful. We have here about reference architectures, but interoperability is not only the exchange of data in a trusted way that every player, both ends of the communication line is understanding each other. It's also how we can secure this data exchange, how we can secure that the data exchange is of a good quality. That brings us to data governance, but also brings us to the term security in operability. And all these standards we have identified, we have assessed, and we are using in EFPF all these standards as a building block to realize, to build the EFPF platform with its tool and services. And in the presentations from the open calls, you have heard perhaps some of you, no, you have explicitly said it, but you're using standards in setting up, in doing your work. And to underline what's the impact to use a standard. It's not that a standard is used for its own purpose, but it's there to build trust on the market. So when you comply with a standard, that means you can demonstrate to others that you have on the safe side, you can have a confidence in the product, in the system, in the service you provide. And that has also a positive impact on the uptake of your solution by the market. And that's also the case for the tools and services of EFPF and EFF later on. So we have created a landscape of standards and standardization bodies operating in the field, in the domain of interoperability. Again, data exchange, security, MQTT, APIs, and so on and so on. And here you can see how many standardization bodies doing their work in that field. It's from STEP, it's from industrial automation, digital twin, and so on and so on. But I don't want to bore you with this figure, and let's go to what we do in EFPF as the next level. We not only have identified the standards we need to use, but we have also seen there's a gap in terms of interoperability to realize the EFPF platform, the EFPF ecosystem. And for this, if a gap is identified, it's assessed, it's critical, we now in the process of filling this gap to build a bridge from the EFPF project to the market uptake of the project results. And for this we have created in 2 years ago at the European standardization bodies CEN and CENELEC a workshop to elaborate what is called a workshop agreement. It's kind of a European standard to have an agreement on how good interoperability looks like in an ecosystem of federating different manufacturing platforms, including a central portal and, of course, a marketplace where you can trade your solutions. And this draft of a CEN workshop agreement, it's here you can remember, you might then remember the number, but you can, yes, you will have the presentations later on anyway. It was submitted for public commenting in summer this year. We have received comments, and we can tell you, and Martin, you are the secretary of this workshop, with Alex as the chair, that this CEN workshop agreement will be made available later this year, and we are in negotiation with the CEN CENELEC Management Center to make this CEN workshop agreement prepaid available, publicly available for download from the CEN CENELEC website. So you don't have to pay to purchase this document. And what's the content of this workshop agreement? To be used as a foundation of, let's say, the standardized foundation of the EFPF marketplace. You can see here the ecosystem requirements, so you can have a trust in the ecosystem, in the requirements. It's a kind of to ensure transparency. You have here also this described reference architecture with the data spine, how the technical aspects of the marketplace, the portal, the matchmaking, all the tools, and the implementation of the EFPF platform as a reference. And of course, also annexed some best practices, lessons learned here from this pilot. So this is in a nutshell. We have standards are there to be used. They build trust. They are of a benefit to ensure that the solutions, when you comply with the standards, are accepted by the market. And that's in a nutshell what I want to make you aware. And we in EFPF have prepared this so that when you use EFPF, it's not only a result of a Horizon-funded project, it's also in compliance with a European standard. So thank you very much for your attention, and if you have further questions, we are at your disposal, especially Martin as the secretary of the workshop and one of, you are in the driving seat of standardization in EFPF, and thank you.
Thank you, Carl. Very insightful presentation, as always. So thank you again, all of you, for this interesting event. I would like to thank the ASI staff, and including the person sitting in the corner who ran the show from behind the curtain. But thank you very much. I don't think this could have been organized in a better way and in such a professional way. I think this was the best setting. Thank you, Carl and Martin, for hosting us and providing this space and making all the arrangements. It was absolutely fantastic. And thank you all the presenters and the participants of this meeting. I hope that you found it insightful and enjoyable and interesting, as we did. The EFPF partners, I'm sure we'll be talking about it for some time now, what are the achievements that we have kind of accomplished together in the project through this open call, and also how we can take it forward and build something on top of it together, of course, with your involvement in our future initiatives and discussions. So now we take a break, and with that break we'll continue with the exhibition. So an opportunity like yesterday for everybody to come and talk to you and discuss some details with you. In this we'll do again the bit of the ranking to make it a bit more interesting and interactive. And within an hour or so after that, we'll conclude with the announcement of the ranking results, and hopefully we will all be very happy to come to that type of ending with that. So thank you very much. Let's take a short break. I think we can close the live stream now. So thank you for the YouTubers who are following us on this on these 2 days, or whenever you caught us. So we hope that we'll see you again in any future event. Please keep in mind that just the last announcement, I think just to remind that the final EFPF event will be on 23rd and 24th of November in Brussels. All of you are invited. It is an event hosted by EFRA and Connected Factories 2 CSA project. So I think they're our community and our people, and EFPF will have a dedicated day on the 24th of November where we will showcase the final outcomes of the project and try to demonstrate the technical solutions in great detail. I'm sure you'll also find it interesting, and I'd like to meet all of you there as well. So let's close the online channel, and for those in the room, let's have a coffee. Thank you.